We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs, what is going on? I don't have my HackerFrogs mascot. What happened? Let me go ahead and reload the program, which has the mascot, and then we will continue. All right, time to start up that program again. Print hello world. All right, let's see if I've got my avatar again. All right, it's there. Awesome, great. All right, everybody, this is HackerFrogs After School. We're doing HackerFrogs After School, and we're doing HackerFrogs Free Hack, and we're doing all sorts of things. Let's talk about what we're going to be covering today on the stream. So today is Wednesday. It is Web App Wednesday, and we are doing web app stuff. So the first thing we're going to do is we're going to do Hack the Web. It's a game we can play, which lets us sharpen up our problem-solving skills. Shota Fujimori, hello, nice to see you here from YouTube. Welcome to the stream. Welcome, welcome. And Game Boy, hello, nice to see you here. Nixie as well. And I saw Sozo and i5. All right, so what are we doing today? First thing we're doing is Hack the Web. That's the first hour. In the second hour, we're going to be doing our Python Basics course. We're going to be playing around with Python and learning how to program in this very popular language. And that's going to be in the second hour of today's stream. In the third hour, we're going to be doing some cross-site scripting labs. We're not going to be covering cookie stealing because cookie stealing is, well, the cookie stealing lab over at PortSwigger, it needs the pro version of Burp Sweep. We don't have the pro version of that program, so we're not going to be doing that. Instead, we're just going to be talking about cross-site scripting in general, and that's going to be the third hour of today's stream. And in the fourth hour, we're going to be doing the OLIcyber website, and we're going to be learning about web app hacking concepts over there. They're probably going to be pretty easy. If we get bored of doing the easy challenges, we will move on to something else. All right, so let me set up the overlay, and then we can get started. So right now, we're doing Hack the Web, and on deck is HackerFrogs After School. Let's go ahead and get started. I'll put 60 minutes on the clock, and then we will begin. Okay, so we're doing Hack the Web first, and Hack the Web is a website where is it? Why is it like this? So Hack the Web is a website where we can do a lot of different challenges. If you're interested in joining along with us, this is the website over here. Psyched, hello, nice to see you here. Welcome to the stream. And if you want to log in without making an account and you can get access to all the challenges, you can log in with these credentials. So the credentials are demo and HTW123 as the password. But without further ado, let's go on and solve the first challenge. So for each one of these challenges, we like to do a little write-up for the challenge because in cybersecurity, they say if you didn't document it, it didn't happen. And we definitely want it to happen, so let's go ahead and do that write-up. So we're doing a walkthrough for Hack the Web. And which challenge are we doing today? So I think we're going to start today by doing the maze challenge. So Syke says, I saw Clippy. Yeah, so Clippy is over here. I'm not too sure what this challenge is, but we're going to be doing the maze challenge. If you feel like doing whatever this is, you can go ahead and try it out yourself. All right, so this is the maze challenge. It's challenge number 72. Let me grab the link, and to anybody who wants to join along with us, that's the link over there. Let's go ahead and make our write-up for this challenge. So this is 072, and it's called, what is it called, Maze? Okay, so for each one of these challenges, we need to record a number of things. The URL of the challenge, the category this would fall under if this was a regular CTF challenge, the concept we need to understand and solve the challenge, and the method of solving the challenge. Okay, and what do we have? We only have the URL at this point. So let's go ahead and move over to the challenge and figure out how to solve it. So this is the maze challenge. So it says hidden in the depths of the website is a maze. Explore it and come back when you have found the treasure. So this, all right. Let's take a look at this maze. Everybody, this is the website that we're hacking against right now. So this is the entrance of the labyrinth. Go to south and west. I wonder if, where do these lead? So maze south, maze west, there's some links over here. And I'm also interested to see if there's anything special inside of the URL, inside of the web page source. So in this case, there's only links. And how are we going to get out of here? All right, so we can try south first because it's the first link. All right, there is nothing to see here. Go south and go north. So, so this brings us to, there's a give up button as well. So south leads back to south. Yucca-ran. Okay, well, hold on. The good thing about this is that at any time we can just reload the page. Oh, wait. We can't just reload the page. This is interesting. I wonder if they give us any cookies for this. So let's go take a look at the web developer tools, and let's go over to the storage for this website. So there's nothing super special about the cookies for the website. So I guess everything is contained within the web page here. So this is maze. Okay, let's try. Well, I mean, we could just try going yucca rat, and we go east, we go north. So it looks like this is the entrance to the labyrinth. Okay. So, I mean, we could try mapping this out. But what happens if we give up? Give up sends us back to the beginning of the labyrinth. Okay. So we go west. This is interesting. I see the so there's east. I see some links. There's east, there's west, south, north. Okay, so can we manually go to these pages? South, and we can go north, and we can go west. So this link give up redirects us to the beginning of the maze again. You know, I wonder what happens if we look at this in curl. So we can use the curl program to take a look at the web page here. Hold on. Let me copy this, and then we'll go over to our favorite terminal over here. Let's just call this one. Let's just call this tab curl. We'll give it a funky color. Great. And we'll start giving some curl commands. Okay, so what do we get? Cannot get? Cannot get. Is that because we don't have cookies? Hold on. Let me see if I can... Oh, okay, I pasted it in incorrectly. Okay, so this works. Oh, it says please log in. So I guess we can't access this page unless we're logged in. So I guess what we need to do is we need to provide cookies. So let me get my cookies. And let's see. So our cookies are over here. More tools, web developer tools, and then storage, cookies. Local storage. Oh, this is view source. Never mind. Okay, now we've got cookies. So this one is called connect.sid. Connect dot sid equals this, and we also need to give the language cookie. I think it's called HTW language preference. So I'll just copy that, go back, and we'll set that one to English. See if we can access it now. Okay, it says there's nothing to see here. So we got give up, and what are we looking at right now? We're looking at the maze. There's nothing to see here. This is 200. And we also, yeah, so this is 200. I wonder if, okay, so we'll go back to the description of the maze. It says, hidden in the depths of this website is a maze. Explore it and come back when you have found the treasure. Come back when you've found the treasure. So this leads to challenge maze. There's nothing to see here. Maze, south, north. This is the entrance to the labyrinth. Okay, so how does the website know where we are? How does the website know where we are? Okay, we got an error over here. Here's the maze, and this is the website. So let me put on some music, because this might be a long stream. Here we go. All right. So this is the entrance to the website. We can go south. Nothing to see here. Go south. Wait, where does that lead us? We go north. When we go south, it leads us to Maze South. Okay, Maze West, Maze North. Neems, hey, nice to see you here. What's good? We're just solving a little challenge over here. Maze South. Nothing to see here. Can we go to Maze South again? Still says nothing to see here. Okay, Maze West. Yucca Rat, go west again. Nothing to see here. Go south. Okay, so I think what we're going to do, this isn't what we usually do, but we're going to look at this website inside of Burp Suite, because Burp Suite is going to let us see all the interactions between the website and what is actually going on in the application. So we're just going to start it up. We're going to start up the Burp Suite browser, and then we're going to start looking at this challenge inside of there. Okay, so let's see. Proxy, open the browser. And where's the website? So the website is this one here. Inside the Burp Suite browser, take a look. They're going to ask us to log in. Okay, I guess we can log in. Let me go ahead and do that. Okay, we need a username and password. And let me get my password. Okay, I shouldn't have logged in. Actually, wait, we'll change our cookie over here to English. Where is this? Where's the thing? More tools, developer tools, and then we're going to go over to application, cookies. I'm going to switch this to English. Oh, wait. Yeah. Language reference is now going to be English. Okay, reload the page. All right. So what challenge were we doing? We're doing the maze challenge. Okay, so maze challenge. Let's access the maze over here. Okay, so we'll try going south and then north. We'll just hit all the directions. And then we will take a look inside of Burp Suite. So in Burp Suite, we can see all the requests that we made. And we can see, let's see, so this is to the maze endpoint over here. Then there is south, and in the response, it redirects us. So where does it redirect us? So redirecting to challenge maze. So challenge maze, okay, and then it redirects us to challenge maze. It says there's nothing to see here. We don't necessarily give any additional parameters here. Okay, then we try going north, and then it redirects us again. Redirecting to Chal Maze. Let's see what's in the request. So in the request, all we're doing is going over to Maze North. It redirects us to Maze again. Nico, hello, nice to see you here. How are you? Okay, let's take a look at the response. So in the response, this is the entrance to the labyrinth, okay? So an H reference to Maze West and Maze South. Day 3, let's get it. What are we talking about? Oh, we're talking about the Python sessions. Yeah, this is day 3. Okay, so there's also give up, and give up redirects us where? Redirecting to Chal Maze. So all of these are redirecting to Chal Maze, redirecting to Chal Maze. They all redirect us to the Chal Maze endpoint. So how are we supposed to solve this? It all seems to be going around in a circle. So can we do some brute forcing attacks? So can we do southwest? Nope, there's no southwest. Okay, so there's no southwest. Is there a south-south? There's no south-south. Is there a north? There is a north. And can we go north from here? So if you try to go north from here, there's no direction. It just redirects you to whatever we have over here. Can we go east from here? So you can go east. Can we go east again? Can we go west? Nothing to see here. Can we go west again? Interesting. I haven't seen a location where we can go in 3 directions before. Can we go east again? I'm really not sure how they keep track of what our progress is in the maze. So I'm just trying to go east over and over again. Can we go north from here? Okay. I get yuck a rat. Where is yuck a rat? South, south. We'll give up. We'll go west, west, west. It's pretty dark in here. So we're getting some special messages. Maybe we really do need to keep track of where we're actually going in here. Let's give up. We'll go west, west, west. And it says it's pretty dark in here. So maybe I'll keep track of a little let's keep track of this. So let's create a little tab. We'll call it text editor, and we'll fire up our text editor in here. Okay. Let's move into the temp directory, and then maze.txt. Whoops, we're gonna edit that file. Okay, let's try making a little map. So let's just say that we start here, s equals start, and then if we go so this is a room, this is west. And then west again, and then west again. So this is the dark room. So D equals dark. So we go west, 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 and we hit the dark room. And then what? So it's pretty dark in here. Go west again. And there's nothing to see here, okay? So we'll call it here. So dark, south, but start here, and then west, west, west. That's the dark place. And JSON IT solution. Hello, nice to see you here. What is up? Okay, so that is nothing. And where can we go from here? We can go... We'll try going west from here just to see if it's possible. West. So I guess we're stuck here. How about we go north from here then? North, nothing to see here. Okay, we'll give up. And we've mapped out this direction here. So west all the way leads to a dark room over here. And then let's try going east all the way. This is the entrance to the labyrinth. We'll try going east. So it looks like they don't want us to go east from here. We can't cheese it like this. Okay, so we'll just try going south. South, south. Spent all day doing the Monday Natus challenges. Yeah, I hope you're having fun. I hope you're having fun. If you don't have if there's something about those challenges that you don't quite understand, give me a shout and maybe I can help you out. There's nothing to see here. So this is us going south a bunch. So even though it says you can't go south, can you force it? No, I don't think you can. West, yucca rat. So we'll give up, we'll go south, and then we'll go south, and then we'll go west. And it says yuck a rat. South, southwest is the rat. So let's... So south, south, and then west. That leads to the rat. Jason IT Solution says, hack the web is still hard for me. I mean, there's a lot of XR, hello, nice to see you here. I've been working on the Leviathan challenges. Awesome. Yeah, as usual, if there's anything you don't quite understand about some of those challenges, let me know and I'll try to help you out. And hack the web, well, I mean, there's a lot of hack the web challenges. So we're doing a challenge we haven't done before, but there are all these different challenges you can check out over here. And if you ever get stuck on one of the challenges, you can take a look at the solution. And I've got the solutions all up and over here. At this link. What is that yucca rat? So, I mean, we can take some cues to see what exactly is going on in the maze. So let's give up. So if we go south and then west, we see a rat. So what happens if we go west from here? West is nothing to see here. So west is just nothing. Okay, so west is nothing. And can we go south from there? We can go south from there. South, then south, then east, then east, then east. I wish you could see further. Okay, so we went south, then south. We want south, then south again. South, then south again, then east. East, and then east. And then it says, I wish you could see further. So we want east, then we went east again, and this is the I wish you could see further. So see further, maybe. We'll try forcing this. So from here, we're going to try force I wish you could see further. We'll go east again. And then we're forced to go west. West or north. Okay. I wish you could see further. We go west from here. And it's just a regular room. And from here we can go east again. And we can go north. So what happens if we go north? We go north. We go north again. Trey, hello, nice to see you here. What's OG? What's good, OG? Hello, nice to see you here, Trey. Okay, so we see we got our maze. It's kind of like this. If we go west a bunch, we should see the rat again. Go. Let's see. There's south, north, and east. Hold on. Let's go south, 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 west. So we go north twice. North, north. And then we can go east. So let's try going east from here. Let's try going east a bunch. North, north, west, 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 south, south. Somehow you have a bad feeling. Somehow you have a bad feeling. So we can go east and north. Oh man. This is a really, what is its significance? Yeah, well, we're trying to solve this maze challenge over here. There's something about the maze that it probably has something to do with web app security stuff. Let's go ahead and get some hints, because we have the opportunity to take a look at hints. Okay, so this is labyrinth, otherwise known as maze. And let's do some translation. So what's the first hint? The first hint is, does someone happen to know how to solve the maze? I just click all the time, and by getting the answers to hope, pencil and paper help much further here. So I guess we are supposed to be mapping out the maze. And let's get another hint. So the second hint is, okay, should it be paper? Doesn't necessarily have to be, but it's probably the most meaningful. Okay, does it need to be paper? The next hint is what? Okay, I cannot get further here. Had you already tried it with the pen and paper, check with the pen and paper, then you should be able to get a better overview, at least slowly. So my guess is that the maze spells out some sort of word after you've mapped it out. But I'm not too sure. Okay, let's man, mapping this out could take a really long time. Okay, the last hint is this. Okay, I already tried it with pen and paper, but either I die or it stands, I run in a circle. The right way should be found in yourself if you try all the possibilities. So, okay, so I guess we need to just map out the thing fully. I don't know if I want to. I don't know if I want to do that. We've already spent about half an hour on this. What are these hints? Well, I mean, they're hints in German, so something might have been lost in the translation. But okay, let's keep on mapping this out then. Okay, give up. This is the entrance to the labyrinth, okay? So start is here. If we can go south and south. South, south, and then we can go west and north. We can go west and north. Apparently there's no entrance, there's no passageway here. So if we go west, we should hit the rat room. West is yucca rat, and then we go west again, and then we can go south. So we can go south, south, and then we're forced to go east. If we go east 1, 2, 3, after going east the second time, we should see a message that says, "I wish you could go further." East, east. What was that? East, east. Oh, we need to go east again, and then it says, "I wish you could go further." So east, east, east. And then the message says, "I wish you could see further." And this goes east and west. So if we go east, then there's the corner that goes west and north. So this portion should be here. Okay, so what can we do from here? We can go north, and then north again. North and then north again, then we've got, what are these options? So the options are east, south, and north. So we could go north again. West, go north because west makes no sense at this point. Okay, let's go. So we're at this intersection right here. We'll try going north. North. Okay, so north is another node that goes north and south. So there is another room here. Like that. North. And then there's another one that goes north and south. All right. I'm running out of room. Okay. So let's go north again. North. I guess we can keep on going north a bunch. How many of these are there? Okay, okay. So we're just going to go keep on going south until we hit the intersection again, and then we'll count how many there are. Okay, so this is the intersection. We should be at this intersection here. We need to count how many times we can go north. 1, 2, 3, 4, 5, 6. 6. So we can go 6 rooms north. 1, 2, 3, 4. Okay, so we can go 6 times. 1, 2, 3, 4, 5, and then another one. So then go east when you're done enumerating this section. Okay, I haven't had to do stuff like this in a really long time. I hope this is entertaining. Okay, so we go 1, 2, 3, 4, 5, 6. And then we need to go east, right? So go east. Is it intriguing? Okay, east. This kind of reminds me of playing like Dungeons and Dragons, where you need to map out your own dungeon and stuff. Okay, so go east, 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 and then it hits a corner. So we'll go east. No, we go west, 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 and then we count how many times. Just numerate if you want. Okay, so how many times? 1, 2, 3, 4, 5, 6. 6 times. So we can go east 6 times. 1, 2, 3, 4, 5, 6. So we can go east 6 times. 1, 2, 3, 4, 5, 6. And then this goes north. It goes north, right? This goes north now. So how many times does it go north? 1, 2, 1, then 2. Okay. So we can go north. One, then 2, and then this splits up into Nokia Snake Game. Yeah, it's kind of like Nokia Snake Game. So we go north twice, and then we're hit with a crossroads. So north, west, and south. So this is west, right? So this is west. We can also go north again. Man, what the heck? Okay, so we're at this place. We'll try going west a bunch. We'll see if west, west. 3 times. 3 times. You hear a quiet beep. Quiet beep? What the heck? So how many times did we go west? I think it was 3 times. 1, 2, 3. Yeah, so that was 3 times. So we can go 1, 2, 3. Beep. Yep. Okay. So from here we can go south and then west. No. We go west. We go west. we go west, and then this is the intersection where we can go north. So we can go east and we can go north. Here, what happens if we go north? North is beep. North, 1, 2. Oh no, we died. Okay, so that leads to death. Okay, so we go north twice and then you die. All right, let's try to recreate that. Let's try to recreate that. Okay, so we go back to try again. Actually, wait, can we go north from here? It says, please log in. Okay. All right, I guess we can go back. This is the entrance to the labyrinth. Great. Okay, so let's go back to where we were. So this is the death place. So X means dead. So this is the beep place. B means beep. So S is the start. So we go south, south, west, 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 and then keep on going until we can go up all the way. I mean, do we want to keep on mapping this out? We know we die here, but we didn't map out this part. Beep equals bomb. I mean, I'm not too sure. Okay, we go south, south, west, west, south, south, east, 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 north, 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 keep on going north. Okay, and then we go east, 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 keep on going east, north, north. So this, I think we are here now. So southwest and north. So we're here. We're at this intersection. So we can go north. If we go west twice, 1, 2, if we go west 3 times, we should get that beep. West, west, west. This is the beep. Okay, so if we go north from here twice, then we die. So we're not gonna let ourselves die if we don't need to. We'll go north from here because we can go north, 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 north. Okay, how many times can we go north? Let me count that. 1, 2, 3, 4. 4 times. Okay. So this is 1. 2. 3, and then 4. And from here, so it's 1, 2, 3, 4. What can we do from here? We can go west, and we can also go north. So this branches off to the west. And it also goes north. Okay, let's try going. So there's a beep here, but we die when we try to approach it. So I think what we should try to do is we should approach this from another direction. So we'll go west from here. So we try going west, 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 west. Okay, so how many times did we go west? One, 2, 3, 4, 5. So that's 5. Okay, so that's... This is how we create a Quake map. Yeah, of course, of course. Okay, so how many of this? How many is this? 1, 2, 3, 4, 5. So from here we can go east and south and north. So it goes off in these two directions. So it goes north and south. Okay, and should we go? So this is where we died. We should probably try to go somewhere around this direction, because yeah, let's try. So we'll go south 2 times, 3 times south, 4 times south. Okay, so we go 4 times south here. One, 2, 3, 4. So where can we go from here? So from here we can go west and north. We can go west. I mean, I guess we could try going west because, you know, we're already here. 1. Oh, okay. So this is a dead end. So west is a dead end. Can we try going west from here? No. All right, so that really is a dead end. So we just keep on going north. 1, 2, 3, 4. So now we're back here. So we'll just keep on going north from here. This map is getting complicated. Go north. Okay, so we can only go south and west from here. So this also goes west. Sykes says Path of Exile, a type of skill tree is what this is. Kind of. Kind of. Okay, so we can go west and south, right? We go west, and then it, yeah, so we go west and then it goes to the north. So we can go north. Let's see where this leads us. North, north, north. So we can go 3 times north. North. North, and then north one more time. Hey everybody, this could be more tedious. You could be the person creating the map. All right, so we can go north 3 times. 1, 2, 3. And then where does it go? All right. We can go east and south. So east, 2 east, 3 east, 3 east, and then it says, am I running in circles here? Okay, so east is this way. 1 east, 2 east, 3 east, and this is talking about circles. C for circles. You know, I'd argue to have paint for something like this, not gonna lie. Yeah, but I don't feel like pulling out the paint, so it's okay. It's okay. Let's just keep on doing this. So we go west, west, west. Okay, so east, 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 and it says I'm writing in circles here. 1, 2, 3. This talks about circles, and then we keep on going east. 1, 2, 3. 1, 2, 3. So from here we can do 1, 2, 3. It's too late at this point. Yeah, kind of. Kind of too late. So we can go south and west. So we go south once, south twice, south 3 times, south 4 times. So this actually does bring us into a circle. Okay, let's connect this stuff. Okay, so now we're back here. If we go north, 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 we should hit a corner. We go north, 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 and then we hit the corner. Yeah, okay. So, man, what do we do from here? So this over here leads to our death. We can go south all the way down, and we can map out the southern part of the maze. All right, let's go all the way south. South, south, south. More south, even more south, even more south, even more south. South, south, south. Okay, so where are we now? We should be, so we can go west, right? Okay. Are we hacking? Well, not real hacking. We're more like doing some problem solving stuff. So we're trying to figure out this maze. This is kind of like your old school RPG maze. So we go west all the way. Now we can go south again. So if we go south all the way again, and we'll go south until we hit the intersection. Text web hacking, yeah, we're kind of like it's kind of like we're playing MUDs again, multi-user dungeons. South. Okay, now we can go east. We'll go east once. Okay, how many times can we go east? 1 east, 2 east, and then we hit another. Okay, where are we? 1 east, 2 east, and then we hit another fork in the road. So we can go east or we could go south. We can go east. We can go south. And thank you very much for following. Monkey Boy Gamer 123. Welcome, welcome. Okay, let's just say we didn't expect to map out a maze. That's okay. Sometimes the challenges takes us in these kind of directions. So we can go south or we could go west. So we'll try going. Might as well try going east. We'll go east. 1, 2 east, 3 east, 4 east, 4 east. 1, 2, 3, 4 east, and then they give us the option to go north, north. Okay, we'll try going north from here. 1 north, 2 north, 3 north, 4 north. We can go north 4 times. 1, 2, 3, 4 times. So after we go north 4 times, where can we go? We can go west. So we can go west. We'll try going west. Sup, thought you were playing a MUD. It's kind of like playing a MUD. We're solving this challenge over here. So the challenge is called Maze. It's challenge number 72 from Hack the Web. Okay, so let's count how many times we can go west. One west, 2 west, 3 west. We can go west 3 times. 1, 2, 3. And then we can go south and east. South and east. We'll go south once, twice. Oh no, somehow you have a bad feeling. Okay, so we went south twice. We'll go north. North. South. South. And this leads to the bad feeling. So the next room is the bad feeling room. So B for bad feeling. Horkrine, hello, nice to see you here. I haven't seen you around in a while. This is one of almost one of those old text-based adventure games. If you ever played one, you'll know that there are two words that do not belong in the sentence. And they're the words adventure and game. Yeah. Okay. So we got a bad feeling over here. Where can we go? We can go east and north. So something tells me that if we go east, this is going to lead to a bad ending. We go east. You died. Okay, so this leads to death. And we've been mapping all sorts of stuff over here. And if you're looking for different content, we'll be doing different content in about 5 minutes or so, because that's when we're going to be starting our next lesson. Holy mapping. Yep. Well, okay, we'll try again. So where did we get to? So we mapped out all this stuff. The start of the maze is over here. We didn't map out this part, I don't think. So let's go and map out this part. So it's south, west, west, south, south. South, south, west, west, south, south. And then we're here. We go east, 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 east. East, 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 east. And now we're over here. So we go north, north, east, east, south. North, north, east, east, south. Okay, so how many times do we go south? We go south 1, 2, 1 and 2. Okay, so we're going... We go south twice, 1, 2, and now we can go where? We can go east. East. Okay, let's try going east. East once, east twice, east 3 times, east 4 times, east 4 times. So 1, 2, 3, 4. So this is a dead end. So it says soda. Do you find an empty soda can? This is probably a dead end. But can we go east again? No, we can't cheat. So do we want to... Okay, I think we can try mapping out this part over here, because this part of the maze killed us. So we'll go west all the way and then north twice. We go west all the way, and then we go north twice, and now we can go east all the way. And then we can go north how many times? North 1, 2, 3, 4 times. 1, 2, 3, 4. And then we can go west. Wait, are we going west? North 4 times. 1, 2, 3, 4. There was no... Okay, I mapped it out wrong. This is west and not east. So we're currently right over here. And so we know that killed us. We've died a couple of times. Let's try going west from the entrance. We'll give up. We'll go west from the entrance. West, west, west and west, and then we can go north. Okay, so west, west. We've got the option to go up from here. So let's go up. Go north. What will I find here? So north. Go south. North. And we get a message, what will I find here? So we'll just label this W. We can go what directions again? North and south. So we'll go north. One, two, three, four, four. We can go 4 times north. 1, 2, 3, 4 times north. So we from the dead end over here, from the crossroads over here, we should go 1, 2, 3, 4, 5 times north. Okay, let me count that. 1, 2, 3, 4, 5. Okay, so we can go west from here. So from here we can go west. West, 1 west, 2 west, 3 west, 3 west. So we can go 3 times west. Okay, we've run out of time. We might come back to mapping out the maze, or I might solve it off stream, but I'm gonna save this. We might come back to this later if we've got some extra time later. All right, let's put another hour on the clock, and we'll do our next part of the lesson. Or sorry, the next part of the stream. The next part of the stream is we're doing Python. So if you're here for Python, let us know by typing in the chat, I'm here for Python. So, I'm mapping so you don't need to. I'm here for Python, and you can add a little PogChamp to that, or some smiley faces. Yeah. All right, let's bring up the lesson. So everybody, we're going to be, if you want to join along with us, we often use the online Python website over here to write our Python code, and you can find the link over here. So on this website, you can put in all of your Python code. You can run your Python code. You don't need to have it installed or anything. And let's see. Over here, I'm just going to get rid of some of these windows because they it bothers me when I've got windows open but I don't need to. Okay, let's just save this as well. We don't know what's going on. All right, so everybody, we're doing Python Basics session number 3. So we might be referencing a bunch of different links in this lesson. They're going to be over here at this link, right? At this link here for session number 3. And let's talk about what we're learning today. Okay, so we're doing HackerFrogs AfterSchool Python Programming Basics Part 3. And we've done a couple of lessons before this. If you're new to this, that's perfectly fine. We might talk about some things that you don't know about. If we cover anything that you're not quite sure about, let us know in the chat. We'll try to catch you up. We don't do anything super complicated over here. We're just playing around with the Python programming language. So what did we learn before? So this workshop is the third intro class to Python programming. During our last workshop, we learned about a few programming concepts through Python, including the following. So we learned about lists. So lists are variables with one or more items associated with them. Items in the list can be referenced by a process called list indexing. So we've got our list over here. Vegetables is a list with carrots and lettuce and beets, but the vegetables 0 object is carrots. The carrots 1 object is lettuce, and the vegetables 2 object is beets. So when we reference by indexing over here, by putting it inside of the square brackets, this refers to the order in the list, and the order in the list always starts from the number 0. So this is 0, 1, and 2. So we talked about basic operations, which is basic mathematical operations using Python. And we're going to be learning about these things today. We're going to be learning about string formatting, which is taking our strings and doing all sorts of fun stuff with them. And we're going to be doing some basic string operations today. So if you don't quite understand what this means, it'll be explained during the lesson. Okay, so we're talking about string formatting. So string formatting lets us use dynamic variables in strings. Lets us use variables in strings, allowing for dynamic print output. So let me demonstrate over here. So if we've got Roblox, huh? I'm going to start writing some code. So what's our example? So name and daily coffee. Okay. So name equals a string. We'll make it the shy hat. And the other variable we're going to define here is going to be daily cups of coffee. That's just going to be a number. We're going to say 3 cups of coffee. So if we want to print out a string using this, we can use print, and we can put a f string in here. So f strings are basically strings that can include dynamic output, which includes variable output. So we're going to put the f string in here. We're going to do a message. So inside here, we're going to put the name of a variable. So name drinks daily cups of coffee a day. All right. So if we have this code here and we run the code, it'll say the shy hat drinks 3 cups of coffee a day. So in this case, because we're using the f string, print with the f here, we can include the names of variables, and the variable names are going to be placed into the string. So this makes it very easy for us to print out dynamic output. Let's continue. So when formatting in this way, we use f strings, which we can use by including the letter f in front of the string when using the print function. So we use the print function, we put the f, and then we put the single quotes or double quotes. Then we can put the variable names in between these squiggly brackets to include them. Inside the string, we can insert variables into the string with the names of the variables wrapped in curly brackets, just like this. So we can also use list objects as part of f strings. So we've got a list about frogs, we got green and jumping. Let's recreate this. List about frogs. We're just going to make this a list. We got green and we got jumping. And we're going to print out a little message with an f string. Okay, and what do we do in the example? This animal is something and moves around by something. Okay, let's do that. this animal is, and moves around by something else. Okay. So in here, we can put in list about frogs object 0 or element 0, which is green, and then we can put list about frogs element 1, which is jumping. So list about frogs, and we've also put in list about frogs here. But in this case, we can reference the first object and the second object. Okay, so when we print this, it should say this animal is green and moves around by jumping. Run that. This animal is green, moves around by jumping. Awesome. Okay, let's move on. So the string formatting exercise. So the string formatting exercise over at learnpython.org is not super useful for our purposes because they use a different type of string formatting. So we're going to skip that exercise. And instead, we can play around more with this. So let's just improvise something. We'll make a few variables. How about we make a bunch of variables about a fictional character? Okay, so we're going to make it some variables: name and age. Age is going to be an integer, and let's see, hobbies. So what is this character's hobby? And what is their job? Job equals something, hobby equals something, age equals something. So let's just say we're doing a 25-year-old character named, I don't know. Shota Fujimori says, I have to, thank you for streaming, I have to go, see you soon. See you next time, Shota Fujimori, and thank you very much for coming by the stream. Let's give you a Nyan Cat to see you off. See you next time. Oreo Bite, nice to see you here. You're asking, how's today going? So we just finished off our first segment of the stream, and we're doing the second segment. We're teaching about Python programming. Okay, so all right, so we're taking suggestions for the name for the character we're creating here, the 25-year-old person. We're also taking suggestions for the hobby and the job. So if you've got a name, a hobby, or a job, let us know in chat, and we'll just plug those in here as the variable names, because we're going to be printing off a little f string to talk about this character. So we're going to print with an f string. This character's name is something. They are something years old. They enjoy doing something, and their job, and they work as a something. So we're just going to plug those in. This character's name is name, and they are age years old. They enjoy hobby, and they work as a job. So we just need to plug those in, and then we can create our little formatted string. Okay, so let's try. Oh, I don't know. Let's just name this character Birdie. Okay, this is Birdie. They're 25 years old. Their hobby is raising tropical fish, and their job is hacking the planet. Actually, wait. So, and they work as a person who hacks the planet. Okay, so OreoByte says, just know that if you're trying to pass or use squiggly brackets in a multi-line string or a string that you have to double it with the f string, which will make it print string be squiggly brackets. So I'm not exactly sure what the message means, OreoByte, but give me an example of some code maybe. So let's run this code. This character's name is Birdie. They're 25 years old. They enjoy raising tropical fish. How about we omit doing here so that it makes more sense? Okay, they enjoy raising tropical fish, and they work as a person who packs the planet. I guess we can put a period at the end of this. But yeah, this makes it so that we can get some really dynamic output when we're printing out our strings. Okay, so let me read OreoByte's message one more time. If you're trying to pass or use squiggly brackets in a multi-line string, or a string that or a string, you have to double it with the f string as str equals f inside of brackets. I've never run into this before, OreoByte. I'm not too sure what an example of that might be. But anyways, let's move on to the next section. Okay, let's talk about string formatting. So we're just going to have a little quiz. OreoByte says, example, instead of having C++ template code in your Python program, you could have it as a multi-line f string. You would have to double each squiggly bracket with the code of the brackets to keep them from breaking Python. Okay, so we're talking about instead of having it outside of your Python code, could you? So OreoByte, I'm having a bit of a difficult time imagining what you're talking about. Could you give me maybe like a paste bin or some code that that illustrates this? Shin, hello, nice to see you here. Welcome to the stream. Okay, let's answer some questions about string formatting over here. Which of the following Python code is a valid method of printing variables and strings? So name equals HackerFrog, print f string hello name, b print hello plus name plus exclamation point, or both a and b, which is C. So the answer is these both work. So you can use either one, the f string with the hello name inside the squiggly brackets, or you could do hello plus name plus exclamation point. These are both going to let you print out variables and strings. Okay, let's move on to some basic string operations. So when you work with strings in Python, there's a bunch of tricks and tips that you can do to get some interesting output out of them. So strings in Python are considered an object class. So when people say that Python is an object-oriented language, that means that each little piece of data inside of Python is considered an object. And in this case, we've got strings such as Seattle over here, and it's a string because you know it's a string because it's between these quotes over here. And then there are straight integers, which are numbers without double quotes or single quotes, and some other classes as well. So classes in Python have special operations called methods, which can be applied to those class objects. So we'll talk about a few of these different methods for string operations. Okay, use of methods in Python code can be identified by the name of the object, followed by a dot, then the name of the method, then parentheses, and any arguments that the method requires inside of those parentheses. Okay, so let's just say that we've got a city. So what's a city that has a lot of the same words in it? Mississippi. Is Mississippi a city or a state? No, Mississippi's a state. Let's illustrate over here. So we got our Python code. We'll just call this a US state equals Mississippi. How do you spell that? M-I-S-S-I-S-S-I-P-P-I, like this. That is how you spell Mississippi, right? If it isn't, let me know, and then I can correct my spelling. Okay, so we're gonna count the numbers of S's in Mississippi. So US state dot count. So this is the name of the method that counts the numbers of letters. And what is it over here? So we can use count with a certain letter, and what it should return to us is the number of letters. Okay, and let's go over here. Let's do the letter S. So how many S's are in Mississippi? Okay, let's run the code, and it says 4. So there's 4 S's. Is that true? 1, 2, 3, 4. Okay. And we could do the same thing with the letter I, say, and let's do the same thing. Okay, there's also 4 I's in Mississippi. 1, 2, 3, 4. That's correct. Great. Okay, let's move on. So basically, what we need to understand is that strings have a bunch of different methods that we can use with them, and they can help us out inside our code. Okay, Shin asks, can we use this with return instead of print? Well, I mean, if we want something to print to the console, we need to use the term print. Return doesn't print anything by default. So if we do, I mean, I'm not even sure. We could do, we could do a function or something that uses count, but it's not really within the scope of today's lesson. Okay, let's move on. Loxley, I'm not too sure how to pronounce your name. Can I bypass OTP? So what kind of OTP are we talking about? So what OTP with sometimes you're able to bypass OTP if the web application that is being tested doesn't have strong protections. So I think I can point you at something you can take a look at. So PortSwigger, what is it? Two-factor. Actually, I think they're just called authentication labs. I can't really spend a long time talking about this because I've got a lesson to teach, but try looking at this. Okay, so use of functions in Python code can be identified by the name of the function followed by parentheses and any arguments that the function requires inside the parentheses. So the example that we're using right here is the len function, which returns the length of whatever string or list that you give to it. So if you've got a really... Yeah, that's right. ShinPDR has the correct lab. Thank you, ShinPDR. Okay, so what we can do is we can count the number of these characters in here using the len function. Let me demonstrate how to do this. So let's just say we've got US state equals Mississippi. We can do the length function. So len with US state. So if we just run this by itself, it doesn't actually give us anything. If we want to print something, we need to put print around whatever we're doing. So print, and then we wrap that around the len function, and then we run it, and then we can get a number. So in this case, the number is 11, and that's the number of letters in here. So we can run this with basically whatever we want. We can also run it with the lists. So let's see, big list equals a list, and we're going to put in a bunch of, let's just say we put in a bunch of letter B's. So B, I'm just going to copy paste this a bunch of times. Hold on. Copy that, and then paste it. You're just going to paste this over and over again to put a bunch of these B's in here. and then we're going to get the length of the big list. So the length of the big list, big underscore lists, and then print that out. And it says there are 20 objects in the list. So when we deal with strings, the length function is going to return the number of letters in the string. If we do it on a list, it's going to give us the number of objects in the list. Bees in the trap. Batman, hello, nice to see you here. Jack, hello, nice to see you here as well. Mississippi, yeah, we're talking about Mississippi here. OLIcyber has a paste bin we can take a look at. Let me take a look at that. Talking about F strings. Oh, okay. Okay, let me show what OLIcyber sent to us. Okay, so we got some code over here in the paste bin. All right, so Python tests username or other string. In this case, oh, this is interesting. All right, so the Python program is taking in user input. In the case, well, the argument. So the string argument here. So hello world username is here, okay? And it's taking in username as username is system argument 1. Okay. Batman Nuka says, what about T strings? I'm not too sure about T strings. What are Python T strings? Template strings. Oh, okay. So, I mean, I'm not super expert about Python, but looks like there's this new thing called T strings. We're not really covering those today. But Batman Nuka, hello, nice to see you here. Let's continue. So we're talking about how to run functions and how to run methods. If we wanted to, we could, instead of using a variable name, we could just put Mississippi between these quotes, and we can also get the answer that way. Okay, let's try running that. Same thing, we get the number 11, which is the number of letters in Mississippi over here. Okay, let's continue. So note that in both functions and methods, inclusion of parentheses are required, even if there are no arguments required for the function or method to execute. So if you run a function, you always need to use the parentheses. Same thing with methods. Even if the methods don't need any arguments to run, you still need to include those parentheses when you run those methods. Shimpidare says, return only seems to work inside of functions. Yeah. So return is usually part of a function, and it's usually used to pass off information to other functions or other parts of the program. It doesn't get saved necessarily, and it doesn't get printed necessarily. OLIcyber says, are T strings like F strings but safer? I'm not too sure. Let's see, Batman Nuka says, nice to see. I'm learning about loops. When will we be getting to those? So let me take a look at when we're going to be talking about loops. We will be talking about loops later on. Just a second. Okay, what's next session? Session 4 is Boolean types and if conditions. I think session number 5. So in 2 sessions, we should be talking about loops. So programming loops are going to be session number 5. Okay, let's continue on with what we're doing right now. Thank you very much for following. Jonas 99, thank you. Okay, so the next method is the index method. So the index method is used to locate the first instance of the argument within the object. The output is the number of characters into the string where the argument appears, counting from 0. So if we've got food equals pizza, so this is a string, we want to know where the A occurs in the pizza string. So we do index A, and it tells us that it is the 4th object. So remember, we go 0, 1, 2, 3, 4. So A is the fourth object if we count from 0. Okay, so I mean, we can also demonstrate this over here. So we're going to do, what is it called again? Index. So US state dot index, and we want to know where the first P appears in Mississippi. So if we want to do that, we can run this method and run it, and it tells us that the answer is 8. So 8 is the 8th index. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it is number 8 if we start counting from 0. Shimbidar says, well, true, message equals subscribe, loop forever. Yeah, I wish everybody could subscribe to my stream forever. Thank you, Shimbidar. Okay, let's go to the next thing. Okay, so here the output is, the method is 4 because we start counting from 0. 1, 0, 1, 2, 3, 4, which means A is at index 4. Count method. So the count method returns the number of times that the argument appears in the object. Note that we don't count from 0 in this case. So we can count the numbers of L and hello. We demonstrated this a little bit earlier. But yeah, this is another handy dandy little method we can use with our strings. Okay, so next we're going to be talking about something a little more complicated. We're going to be talking about string index slicing. So just as we can index lists to retrieve the item contained at a specific position, we can index strings with each character in the string counting as a separate item. So when we do list indexing, each object in the list is an index. But when we deal with string indexing, each character is an object inside the string. Python 3, Pi, done. Better way to do it. Okay, so let's talk about string indexing now. So remember, when indexing in Python, counting starts from 0 instead of 1. This is something we need to remember over and over again, because when we do computer programming, we love counting from 0. So what's more interesting is the ability to select specific slices of the string, and here we've isolated the third and fourth letters from the string Python. So if we got a pet is equal to the string Python, if we print the pet string, but only starting from the second index and stopping before the fourth index, then we get the two letters T and H. So the first letter is where we begin. So this is index 2. So this is 0, 1, 2. So we start here, the T, and we stop before the number 4, or index 4. So 0, 1, 2, 3, 4. So index 4 is O, but we stop before that, and we get H. So just T and H. Shembidiar asks, how many programmers does it take to change a light bulb? 35, 1 to fix it, and 34 to say I can do. Okay. Anyways. Print, yes, queen. Okay, all right, everybody. So inside the brackets, we indicate the character to start from, counting from 0, then a colon, and then the character that marks the stopping point, which is not returned. So let's just pretend we've got a big string over here. So we got the U.S. state Mississippi, and what we want to do is we want to just get these 4 letters, Miss. So we can print U.S. state Brennan Lavelle, stop asking if we can help you hack websites. We don't do illegal stuff over here. If you ask again, I'm going to have to time you out. Shimbier says, last day of examination, I'll leave for now. Happy learning, y'all. Hey, have a great one, ShinBDR, and let's give you a hack the planet to see you out. See you next time.
Hack the planet! Hack the planet!
PFX asks, do you do DDoS? Yeah, once again, don't ask people to do illegal. Don't ask me to do illegal stuff on my stream. This is a warning, PFX. If you ask me to do illegal stuff again, I'll time you out. Okay, so US state. Let's start with the 0 index, and we'll stop before the I over here. So the 0 index is the letter M. We'll put a colon, and so 0, 1, 2, 3, 4. So if we get this slice over here, starting at 0, ending at 4, we're just going to get the letters MISS. Okay, print that, and we get just the letters MISS. Okay, so this is an example of string indexing over here, or string slicing rather. Okay, let's continue. So in this case, 2 and 4 indicates to start from the 3rd character, to stop at the 5th character, and not included in the output. So we can also add a second colon when we do our string index slicing, and that's the number of characters to count by when slicing. So in this case, we got our centipede. So bug equals centipede, this is a string. If we do the slice of the bug variable, starting from 0, ending before 9, and counting by 2, then we get these characters right here. So we start from 0, which is C. We end at 9, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is basically the end of the string. Shane BDR says, 1 to say it works on my machine, and 34 to ask why and how. That seems like more like my experience with programming, because because it always works on your machine, but it doesn't necessarily work on everybody else's machine. I thought Docker was supposed to solve these problems. Okay, so let's see. So we're basically using the entire string here. And we're just going to print out every second string, because the number 2 here is what that indicates. So we got C, and then N, and then T, and then E, and then E, which is exactly what we print out here. We can demonstrate it over at print Python over here. So we got our US state Mississippi. So we'll start with the beginning of the string. So how many characters? So 0, 1, 2, 3, 4, 5, 6, 9, 10, 11. So we will 0 and then colon 11 and then colon 2 to get every second letter. Mud Skipper says, just popped in to say I love your content and usually watch some videos. Thank you for the constant work you put in it and for teaching style. Your teaching style is great. Thank you very much, Mud Skipper. The shy OreoBed asks, anybody able to run Windows Docker on a Linux machine? Seems like the last time I tried it. You can only run native OSs in Docker. Not exactly sure about that, OreoBed. I've never really run Docker inside of Windows. Okay, so let's try printing out every letter, well, every second letter in the word Mississippi with our string slicing right here. We'll try that, and we get MSISPI. So MSISPI, just like this. Okay, let's move on. So the last part of string indexing that we're going to cover is using negative index numbers. So when we do our string indexing, instead of starting from the beginning of the string, from left to right, we can also go right to left by using these negative numbers here. So if a negative index number is used, the index starts counting from the end of the string instead of the beginning of the string. So if we print fruit, but we get the index -1, it starts at the end of the string and we get the last letter here. So if we demonstrate this over here, and we just get the last the last letter of Mississippi, it's going to be I, and we reference it by -1 index. So that's the letter I. If we do -2, it's going to be the second from the last. So it's I and then P. So this gets us the P, okay, etc., etc. All right, so before we go on, let me put on some other music. Okay. So when indexing, if we include a colon without a number to its left, the first colon will have a default value of 0, which is the start of the string. And the second colon will have a default value of the number of characters plus 1, which is the end of the string. So if we do the string indexing like this, if we just do colon as our string indexing over here, so instead of a number, we're just going to put a colon in here. So this is basically going to be the entire string. If we run this, we get Mississippi. It's just like as if we were printing out the string normally. So here the whole string is in range due to the inclusion of 2 colons with no numbers to the left of them. And we're stepping through the characters in reverse order one by one. So here we've got 1 colon, another colon with no numbers to the left of them. That means they take their defaults. The last number is -1. And if we do the last number as -1, we go backwards in the order. So in this case, we're printing out the full string, grapes, but in reverse. So S, and then E, and then P, etc., etc. We can demonstrate this over here. So the string indexing, we do 2 colons, and then we do -1. This means it's going to start at the end of the string, and it's going to spell it out to the beginning of the string, which is the letter M. And we get Mississippi, but backwards. Ronan says, do you mean something like Docker/Windows? Last time I checked, it worked for me, but I used Windows. Why on Linux does it not work? This looks like the conversation. Hello, Ronan. Nice to see you here. No worries. All right, so that's string index slicing. We got a bunch of methods that we're going to be dealing with here too. So the upper and lower methods output all the characters in uppercase or lowercase respectively. So if you run the upper method, it's going to be all uppercase. If you run the lower method, it's all lowercase. So let's, that's a bit loud. Just a second. Okay, let's go over to our online Python. So instead of a US state, let's just say US full name. So the full name of the US is the United States of America. Okay, so what we can do is we can print out US full name, and then we can apply the upper method to it, which means that it's all going to be in uppercase. Mano Vikram, hello, nice to see you here. Good recommendation by YouTube. Hello, nice to see you here. We're just doing some programming stuff. We're going to be hacking some web stuff later. So if we run the upper method on this string here, we're going to see that everything is going to be output in uppercase. And we can also run the same thing with the lower function, or the lower method. Lower, and then everything's in lowercase. Sofiane, hello, nice to see you here. Thank you very much for the session. Yeah, so I mean, it's important to learn how to do some basic programming. Python programming doesn't need to be intimidating. We just need to get our hands on the keyboard and start doing some experimentation. And the best way to learn about Python is to start writing some code. Okay, let's continue. Upper and lower. starts with and ends with methods. Okay. So these are two methods that can be used to test whether strings contain the specified argument at the start or the end of the string, respectively. So these two methods here, they return true and false. It's either in this case, it starts with the letters the, or it ends with the letters frog. So Fiona says, I'm on Cyber and I'm not too sure what is. Let me know about that. Would love to learn Python. Thank you. Weatherzone says, I just found your channel. I downloaded Linux 2 days ago and I love it. Trying to learn more. Yeah, we just finished doing a Linux crash course. If you take a look at the live streams from last week and a couple of weeks ago, for example, we were doing a crash course on how to use Linux. Okay, so let's demonstrate these two methods here. So it starts with and ends with. So we got our online Python here. If you want to try it out, online Python is this. Okay, so US full name. This is a string. It's the United States of America. Let's do US full name starts with. So starts with is the method, and we can check if it starts with the. And this is going to print out true or false. Does it start with the, or does it not start with the? If we run this, it says it's false. Can anybody tell us why this returns false? So we're checking if this string starts with the. It says it does not. Weatherzone says, awesome, I will watch those live streams. Thank you. Thank you very much, Weatherzone. So the reason why this returns false is because, well, I mean, it takes capital letters into consideration. It does not start with a lowercase t, but a capital T. So this is why it returns false. So if we come back here and we replace the lowercase t with the capital T, now it returns true. Uppercase T, yes. Hello, nice to see you here, and welcome on YouTube. Okay, so if we do ends with instead of starts with, so ends with, let's just say Rika. Does it end with the letters RICA? We'll run this. It says it is true, because this string does end with this string here, RICA. If we put a space in here, then this is going to return false because it does take this kind of stuff into consideration, this white space. Now it returns false. So we can also ask if it ends with America with the space over here. And it should also return true in this case as well. So this is also true. These are not methods that you're going to use super often, but it's nice to know that they're there. Okay, the split method. This is actually a method you'll use quite often. Well, at least I use it pretty often. Yes says, oops, the stream was delayed, so I answered late. No worries. That's fine. So the split method, it's going to convert a string into a list with the separation between the items indicated by the argument given. Usually it's going to be a space or a comma. So we got Null. Thank you very much for subscribing on YouTube. Welcome to the stream. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it!
Okay, so this is the split method. It takes a string and it turns it into a list. So what we do is we make a new variable here. Grocery list equals groceries, which is a string, and then we split it by the commas. And when we print out that list, it's going to be a list, and it's going to have each one of the items in here. We can demonstrate this. Okay, let's just do a string. The string will have fruits. We're going to call it the fruits string. Okay, so this is going to be a big list of fruits: oranges, apples, bananas, pineapples. Oh, what other fruits? Kiwis, watermelon. Okay, so just like this, we're gonna make a new thing called our fruits list, and it's going to be fruit string dot split by the commas here. Thank you very much for subscribing, Sofiane. Okay. So Brendan, I'm gonna have to time you out. Okay, so here we're going to split this string and turn it into a list, and it's going to be split by the commas here. So we're just going to print out the fruits list. GroudXT, hello, nice to see you here. Yeah, you haven't been by in a hot minute. That's fine. We're just teaching some Python over here. Okay, let's run that, and it should give us a list because we ran the split method on the string. Okay, so we got our list of fruits over here. This is actually it's pretty useful because often you're going to find like a list of things on the internet, and what you want to do is you want to put it into a list when we're working with Python. When we're trying to run some things through the list. Okay, let's move on. We're going to do our basic string operations exercise. And you know, instead of doing the basic strings operation exercise, I've got something more fun we can do. We'll do the strings operation quiz first, and then we'll start solving some challenges over at PicoCTF. Okay, so what is the output if we use the following code? Print HackerFrogs split indexing 6, -1. GredXT says, Docker's on fire and not pulling images if you had any of them planned. Oh, interesting. I don't think I'm going to be using too many Docker containers for today's lesson. Okay, so what's going to print out if we do HackerFrogs sliced by 6, -1? Okay, so it's either going to be frogs, it's going to be FRO, it's going to be frog, or nothing will print, the syntax is incorrect. So remember, we're starting from 6. So this is 0, 1, 2, 3, 4, 5, 6. So it should be the letter F here. Tom, wee says B, okay. I don't think that is 6. So 0, 1, 2, 3, 4, 5, 6. So it should start with the letter F. So it's either going to be A or C. Okay, and the answer is C. It's just going to be frog. So we can actually check this. We'll check this. Go over to the code here. So frog. The reason why the final S doesn't print out is because the final character is not included in the output. Okay, let's move on. So workshop review exercise, what we're going to do is we're going to write a program that records your full name, first and last name, then tells you what your last name is and how many letters are contained in it. Okay? Yes, as I don't really know Python that much, but I understood it. It starts with 6 and -1, so it only reads 5. Yeah, that is exactly how it goes. Okay, so we've got our code. It's over here. So the important thing is that we understand what the code is doing. So I'll just, okay, everybody, the link is here. The link is here. Go down to the end of the GitHub page, end of session exercise code. You can copy the code here by clicking on this button, or you can just copy it by highlighting everything and copying it like that. Go over to Online Python and then paste in your code. So what do we have? So we got full name equals input. What is your full name? And this is user input, which means we get to type that in. Sofiane says, so the -1 will be for getting backwards the whole thing and also to exclude the last character. So -1 doesn't mean backwards necessarily. It means the last character. So the last character in the line. Okay, so split name is going to be full name dot split. So split name is going to be a list. So it's going to be split by whatever you put into it. The last name is going to be split name 1, which is the list and the first element with element 1, which is the second thing in the list. Last name length equals length of the last name. Your last name is something, and there are last name length letters in your last name. Okay, Tom, we has just subscribed. Thank you. Okay, so if we run the program, it's going to ask us, what is your full name? So we can answer the Shy Hat. And it says, your last name is Shy Hat. Okay. There are 6 letters in your last name. So it basically counts up the number of letters in the last name, which is split. What is your full name? I think we can put in space there too. So we'll run it again. And let's try a really long name. So let's try Abraham Lincoln. How do you spell Lincoln? Like that, right? Okay, your last name is Lincoln. There are 7 letters in your last name. So Lincoln is, yeah, okay, that is it. And 1, 2, 3, 4, 5, 6, 7. Great. All right, that works. We'll do one more thing in today's lesson for Python. We'll do, where is it? We're going to do the password crack challenge over at PicoCTF. So PicoCTF is a website that we like to use when we're learning about cybersecurity stuff. It's over here at picoctf.org. You can make an account on PicoCTF for free. So after you've logged into the website, what we're going to do is we're going to access the web shell. So after you log into PicoCTF, click on Practice, and there's going to be the web shell button on the right-hand side. So you can click on it. Oh, I noticed that we've got an ad running on Twitch right now. Okay, so we'll just run an ad on YouTube, and we'll take a little water break. While we're doing our water break, I'll show you all some birds. I just need to take a little water break. We'll be back in about 20 seconds. Okay, we'll put the birds away. We'll get back to the hacking. So, okay. So we're on PicoCTF. Once you're logged in, you can click on the web shell button, and then you can put the web shell in its own browser tab. The way you do that is you click on this button over here. It's beside the help button. And so what the web shell is it's a Linux web shell terminal. It's a Linux accessible version It's a web accessible version of Linux is what it is. And this is what we're going to do. We're going to be using this to solve a challenge over at PicoCTF. So this is the cybersecurity website that we like to use. And the challenge we're going to be solving is this one. So password crack 1. Here is, here's the link. So go back to PicoCTF, paste in the link. And this is the password crack 1 challenge. The reason why we're solving this challenge is because it involves us using Python code. So the challenge here says, can you crack the password to get the flag? Download the password checker here, and you'll need to get the encrypted flag in the same directory too. So this is what we're going to do. We're going to highlight the first link. There are 2 files that we need to download here. So highlight the first link, and then right-click, select copy link. So hover over the link, right-click, copy link, and then go over to your web shell. So in the web shell, we're going to give some Linux commands to download this file. So type in wget and then space. So wget is the command that's going to download the file. Right-click, select paste. This is going to paste in the file location. After you've done that, hit enter to download the file. And when you do the ls command to list out what's in your directory, you should see that level1.py. This file is now in your directory. We're also going to be downloading another file. We're going to go back to the PicoCTF challenge, and it says you'll need the encrypted flag. So flag is also a link. Right-click on it, select copy link, and then go back to your web shell. In the web shell, type in wget again, space, right-click, paste in the file address, hit enter to download the file, and now you should have 2 files in your directory. So it should be level1.py and level1flag.txt.enc. So if you got both of these files in your directory and you're following along, please let us know in the chat. Type in, I have those files, smiley face. So after you've downloaded these two files, what we're going to do is we're going to run Python to solve this challenge. So in Linux, we can run Python files, which are files with the .py file extension, by just typing in the word Python and then the name of the file we want to run. So the Python file in this case is called level1.py. So Python space level1.py. Hit enter to run the file. It says, please enter the correct password for flag. We don't know the password. So we can type in test, hit enter. It says the password is incorrect. So what we can do here is we can take a look at what's actually inside the script file. So level1.py, we use the cat command to read the script file. So there's Python code in here. So when we read the file, we don't need to pay attention to anything above here. We just need to pay attention to this part of the file. So can anybody tell me what the correct password is? If we look at this file here, we're trying to figure out what the password we need to input to the program. So it runs the input function here, and it asks us a question. Please enter the correct password for the flag. And they do a little if statement here. We're going to be talking more about if statements in the next lesson, but there's a password we need to use. So yes says it is 691D. So that is correct. So if user password, which is the variable we're creating right over here, is equal to 691D, then we're going to print welcome back your flag, and then it decrypts the flag and then it prints it out. Otherwise the password is incorrect. So let's go ahead and use this information here. So 691D, we'll run the Python command again. So Python space level1.py. Sozo says, good evening. Hello, nice to see you here. So 691D, and then hit enter. So welcome back, your flag user. Okay, so PicoCTF, this is the flag. So the flag might not be the same for everybody else, but copy your flag, then go back to the PicoCTF exercise, and in the challenge description here, you can paste in the flag and then click on Submit Flag. And then you're finished. Okay, everybody, we're essentially finished today's lesson, but I really want to illustrate how when we're using Linux, we have to interact with these Python scripts in a specific way. We need to use the Python command, we need to give the name of the script, and we need to run that stuff. We can also edit these. We can also edit the scripts if we really want to, and start mucking around with the code. But in this case, we don't want to do that. All right, let's do our summary of what we learned today, and then we'll finish up. Okay, so let's review the programming concepts we learned in today's workshop. We learned about string formatting. So string formatting is a way for us to include variable values in strings by using f-strings. So this is the way I usually format my strings when I want to print off stuff for my programs. And we learned basic string operations. So strings in Python have a number of different functions and methods that can be useful for obtaining specific details about the strings. So for example, we could run the count method, or we could do string slicing. So we can also output slices of strings through string indexing. So something like this. String indexing it can get a little complicated at times. It's not super intuitive. So if you need to ask questions about this, that's perfectly fine. So what's next? In the next HackerFrogs After-School Programming Workshop, we'll continue learning Python with the learnpython.org website. Well, maybe not. Renan says, if you're on YouTube, you can run the video on 1.5 until you can catch up to the real time of the live without delay, or come to Twitch. Yeah, I think most videos are more enjoyable when you run them on 1.5 or at 2 times speed. But that's just me. Okay, so in the next workshop, we're going to be talking about the following things. We're going to be talking about loops and functions. This is a bit out of date. We're not going to be talking about loops and functions. Let's talk very, very quickly about what we're doing in the next session. So in the next session, we're going to be talking about Boolean types and if conditions. So Boolean types are true and false, and if conditions is if this is true, then run some sort of instructions. So that's what we're doing next time. And next time is going to be on Friday. Today's Wednesday. Next lesson is on Friday. Okay, so hope to see you there. And until then, well, have fun with your Python. Okay, let's do the next part of today's stream. Put 60 minutes on the clock. And what we're going to be doing next is we're going to be talking about PortSwigger cross-site scripting labs. You know, I just noticed right now that my topics are not correct. So this is Python session 3. Just a second, everybody. And we're doing OLIcyber web challenges. Okay, let me straighten that out. Okay, so we're doing topic 3, which is PortSwigger cross-site scripting labs, and on deck is OLIcyber web challenges. Okay, so we're going to be using this as a reference for learning about cross-site scripting. So cross-site scripting is a very, very common and sometimes very serious web app vulnerability. So we'll talk about it. We're going to be working through some labs to understand what cross-site scripting is. And, well, it's been a long time since I've taken a close look at cross-site scripting, so I'm going to be teaching myself something about this as well. Okay, so let's begin. So in this section, we'll explain what cross-site scripting is, describe the various different varieties of cross-site scripting vulnerabilities, and spell out how to find and prevent cross-site scripting. So cross-site scripting, which is usually called XSS, web app security vulnerability that allows an attacker to compromise the interactions that users have with a vulnerable application. So it allows an attacker to circumvent the same origin policy, which is designated to segregate different websites from each other. Cross-site scripting vulnerabilities normally allow an attacker to masquerade as a victim user. Thank you very much, Saint of Vice. You're now HackerFrog. Welcome to the stream. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get in.
Okay, if the victim user has privileged access within the application, then the attacker might be able to gain full control over the application's functionality and data. So how does cross-site scripting work? Saint of Vice says, sup. Hello, Saint of Vice. Nice to see you here. We're just going to be learning about some cross-site scripting vulnerabilities. And, well, it's something that happens a lot inside of web applications. They're usually vulnerable to cross-site scripting because of some bad code. Cross-site scripting works by manipulating the vulnerable website so that it returns malicious JavaScript to users. So another thing that we can think of, instead of using the word cross-site scripting, we can think of the word JavaScript injection, because cross-site scripting makes use of JavaScript, and it basically gets malicious JavaScript commands to run inside of another person's web app session. When the malicious code executes inside the victim's browser, the attacker can fully compromise their interaction with the application. Okay. So what do we got here? So we have a user who puts in a cross-site scripting payload into their application. And what it does is it feeds sensitive data like the mother's maiden name, the password, and maybe a wire transfer over to the bad person. All right. So we got some labs that we can use to learn about cross-site scripting. And first, we'll talk about the proof of concept for cross-site scripting, otherwise known as XSS. So you can confirm most kinds of XSS vulnerability by injecting a payload that causes your own browser to execute some sort of arbitrary JavaScript. It's been a long common practice to use the alert function for this purpose because it's short, harmless, and pretty hard to miss when it's successfully called. In fact, you solve the majority of our XSS labs by invoking alert in a simulated victim's browser. However, there's a slight hitch if you're using Chrome from version 92 onwards. Cross-origin frames, iframes, are prevented from calling alert, as these are used to construct some of the more advanced XSS attacks, and you'll sometimes need to use an alternative proof of concept payload. It's Austin asks, I have a question. Are you familiar with KDE? KDE? The acronym seems kind of familiar, but I'm not super familiar with KDE. So does that has something to do with programming and development? Development KDE? A cross-platform IDE for C, C++, Python. Oh, okay. So this is a development environment. I mean, I don't really use IDEs because I'm not much of a developer, but yeah, good to know about this stuff as well. Okay, let's continue. Where are we? So as a simulated victim in our labs, as a simulated victim in our labs uses Chrome, we've amended the affected lab so that they can also be solved using print. So we've indicated this in the instructions wherever relevant. Okay, so what are the three types of cross-site scripting attacks? So there's reflected XSS, there's stored XSS, and there's DOM-based XSS. So reflected is, well, we'll go ahead and go through them. So reflected XSS is the simplest variety of cross-site scripting. It arises when an application receives data in an HTTP request and includes that data within the immediate response in an unsafe way. So here's an example of reflected XSS vulnerability. Okay. So we have a domain, and then we've got a URL parameter. So the parameter is message. Kubuntu. Kubuntu is that's another distribution of Ubuntu, isn't it? Message is all is well, but we've also got some HTTP tags that have been included as well. So the application doesn't perform any processing of the data, so an attacker can easily construct an attack like this. So let's see, insecure website, and then inside of the message parameter, we've got our script tags, which we can use to write some malicious JavaScript. Okay, we'll talk about this in a little bit. So if the user visits the URL constructed by the attacker, then the attacker's script executes in the user's browser. In the context of users' sessions within the application, at that point the script can carry out any action and retrieve any data to which the user has access. Thank you very much for following Job Avoider. Job Avoider, welcome to the stream. Have a fun Nyan Cat as a fun little treat. Okay, so most of the time when you're talking about cross-site scripting attacks, it's basically where you trick somebody into running a link that has a cross-site scripting payload. So if you've got people trying to send you links and they want you to click on them, you might not want to click on them because when you click on them, they might lead you to a website that runs a cross-site scripting payload and then does bad stuff to your computer. Okay, let's talk more about this. So the next type of cross-site scripting is stored cross-site scripting. So stored XSS, also known as persistent or second-order XSS, arises when an application receives data from an untrusted source and includes that data within its later HTTP responses made in an unsafe way. So basically, stored XSS is where you can write a cross-site scripting payload to a web page. So here's an example of a stored XSS vulnerability. A message board application lets users submit messages which are displayed to other users. So we've got, hello, this is my message. The application doesn't perform any other processing of the data, so an attacker can easily send a message that attacks other users. So whenever somebody loads up the forum, it's got an XSS payload on the forum pages, so when they load up the page, then bad stuff happens. And what is the last type of cross-site scripting? This is DOM-based cross-site scripting. So DOM-based cross-site scripting, also known as DOM XSS, arises when an application contains some client-side JavaScript that processes data from an untrusted source in an unsafe way, usually by writing the data back to the DOM, the DOM. Okay, let's go ahead and play some music, and we'll continue. Okay, so in the following example, an application uses some JavaScript to read the value from an input field and write that value to an element within the HTML. Okay, so something gets saved through user input. Smooshkid says, ask the LLM the same thing that you're asking chat, give it whatever version of Linux you're using, what you're trying to accomplish, and the issues you're running into. Maybe include some screenshots of error messages or whatnot. Yeah, I mean, a lot of people need to know that you can use LLMs to solve a lot of your technical issues, and sometimes it's faster than trying to search for answers on forums and stuff. Okay, so if an attacker can control the value of one input field, they can easily construct a malicious value that causes their own script to execute. So you searched for image source equals 1 on error, and then a bunch of cross-site scripting stuff there. So in a typical case, the input field would be populated from another part of the HTTP request, such as the URL string query string parameter, allowing the attacker to deliver an attack using a malicious URL in the same manner as reflected cross-site scripting. Neem says, I was just working on DOM base today. I'm terrible. I'm pretty sure I'm going to be pretty terrible at cross-site scripting right now as well, because I haven't taken a look at cross-site scripting in a couple of years. But it is something that comes up over and over again. So what can cross-site scripting be used for? An attacker who uses cross-site scripting is typically able to impersonate or masquerade as the victim user, carry out any action that the user is able to perform, read any data that the user is able to access, capture the user's login credentials, and a bunch of other stuff. So the impact of cross-site scripting vulnerabilities, the actual impact of cross-site scripting attacks generally depends on the nature of the application, its functionality and data, and the status of the compromised user. For example, in a brochureware application where all users are anonymous and all information is public, the impact will be often minimal. So in an application holding sensitive data such as banking transactions, emails, and healthcare records, the impact will usually be more serious. Okay, so, hold on. I want to go over to the cross-site scripting labs. Where are the labs? Here are the labs. All right, so we got a bunch of labs talking about cross-site scripting. Let's try and solve some of these. Okay, let's go over to this lab over here, reflected cross-site scripting into HTML context with nothing encoded. This is the lab we're looking at right now. Okay, so in this lab it says the lab contains a simple reflected cross-site scripting vulnerability in its search functionality. To solve the lab, perform a cross-site scripting attack that calls the alert function. Okay, so we're going to load up the lab. Oh, I need to log into my PortSwigger account. So everybody, so PortSwigger is a really good website to learn about web app vulnerabilities. Neems asks, what are you best at within all of the labs? So what am I good at testing within these labs? Hard to say. I mean, I like file upload attacks. I like file upload attacks. I like OS command injection. That's always fun. File inclusion is another fun vulnerability that that you encounter a lot on your beginner level CTF challenges. And let me log in to PortSwigger. So PortSwigger Academy, okay. Paste that in, log in. Just a second, everybody. Easiest for me would be path traversal. Yeah, path traversal. IDOR is also a pretty easy vulnerability to spot most of the time. Okay, so we've got our lab over here, and what we need to do is we need to do cross-site scripting. So to solve the lab, perform a cross-site scripting attack that calls the alert function. And it says the lab contains a simple reflected cross-site scripting vulnerability in the search functionality. So if we go back to the lab, we've got our search functionality right here. So search the blog, and what we can do is we can just put in our script tags. So the easiest cross-site scripting vulnerabilities are just going to be put between these script tags like this. So this indicates to the HTML page that we're running some JavaScript. So we would run alert, and between the parentheses we would run something like we have XSS over here. Okay, and then run that. And then we get a pop-up that runs some JavaScript alert. We have XSS over here, and then we're finished with the lab. So that's all we needed to do. We just needed to prove that this website is vulnerable to cross-site scripting. Okay, let's move on to the next lab. Okay, we solved that one. Let's go back. Let's go back. Okay, so cross-site scripting, let's move to the next one. So the next one is another one. So stored XSS into HTML context with nothing encoded. Great. Okay, what are we doing in this lab? And this is the lab here. If you're logged in to PortSwigger, then you can do the lab along with us. So this lab contains a stored cross-site scripting vulnerability in the comment functionality. Okay, stored cross-site scripting vulnerability. So this is stored XSS, and we're looking at the comments. So solve the lab, submit a comment that calls the alert function when the blog post is viewed. Okay, we will open the lab. So the really nice thing about these labs is that the lab environments here are all individually spun up. So these are all virtual machines. They're virtual machines that run in the cloud, and they're hosting these web applications. And they spin up within seconds. It is very, very responsive, and that's really nice. Okay, so we got blogs over here. So we're going to view one of these posts. Sure. And we can leave a comment. So what we want to do is we want to leave a comment that has a cross-site scripting vulnerability. So what does the lab description say? So the stored cross-site scripting vulnerability in the comments. So to solve the lab, submit a comment that calls the alert function when the blog post is viewed. We're just going to leave a comment. In the comment, we're just going to put in our script tags. So script, and we're going to put an alert in here. We have XSS up in here. Okay, and then we'll leave the comment. The name can be, I don't know, the HackerFrogs or the Shy Hat. Test at hackerfrogs.com. Website, http www.hackerfrogs.com. Okay, post the comment. Okay, your comment has been submitted. It says you have solved the lab. So to prove that we've solved the lab, we can go back to the blog, and then we get the alert message. We have XSS up in here. Okay, that's done. Next challenge is, what is it? DOM XSS in document.write sync using source location.search. Okay, let's take a look at the next lab. Neem says, I did that as well today. I didn't know you should test each field for XSS. Yeah, I mean, you could put XSS into, you should test each one of the fields because they could individually be vulnerable to cross-site scripting. Okay, what's going on here? DOM XSS and document.write sync using source location.search. So this lab contains a DOM-based cross-site scripting vulnerability in the search query tracking functionality. It uses the JavaScript document.write function, which writes the data out to the page. The document.write function is called with data from location.search, which you can control using the website URL. To solve the lab, perform a cross-site scripting attack that calls the alert function. Okay, let's put that in another tab. So once again, we're trying to get our cross-site scripting payload to go off to create an alert. So location.search. So when it says that we're dealing with location.search, I'm pretty sure we're dealing with this over here, the search bar. Let's try posting in our script tags. So script alert. We have XSS up in here. Okay, put that in. So we got 0 results for script alert. We have XSS up in here. I mean, it looks like it didn't work. Did it not work? Let's reload the page. Soul Emanator says, would you be able to inspect the element to verify? So inspect the element. Here. So this is where we have our payload, but it looks like the payload didn't go off. So we're gonna have to do a little more research. Okay, perform a cross-site scripting attack that calls the alert function. So it uses the JavaScript document.write function, which writes data out to the page. Document.write. It's called with data from location.search. I mean, there's not too much else we can do on this page. The other thing that I'm thinking is that there might be some sort of filtering going on, which could be getting in the way with our payload going off. Okay, we can go back home. View post. Oh, you know what? It might be in here. So we also have a URL parameter. So the post URL parameter in here. Let's try putting it in there. So we got our comments. I mean, test@test.com, website, whatever it is. We can try putting it in here. Back to the blog. Yeah, so it doesn't work here. We could also put it up in the URL parameter. So post ID equals, and we can put our script up in here. Invalid post ID. Whoops. Okay. So I think we were also talking about the search function. So the search function is here, test, search equals test. So search equals test. Instead, we can just put in our cross-site scripting payload. Neem says, that's where I get stuck as well. I had to watch a video. Yeah, like I said, I haven't done any cross-site scripting in a really long time. All I remember is how to do the typical like alert payload. Did you try to escape the last line and then put your payload in? So escape the last line. Okay, so did I go full screen for this? Hold on, everybody. How do I get it at full screen in my browser? I think I hit some key by mistake. So it's like Firefox, browser full screen. F11, is it F11? Yeah, it is F11. Yeah, thank you very much. Sometimes the thing you don't want to do the most is you don't want to DOM access in document write using source location.search. So let's see. DOM XSS cheat sheet. Okay, so cross-site scripting cheat sheet 2025 edition. So this is from PortSwigger, so it should have some pretty good stuff in here. Okay, so let's see. Copy tags to the clipboard, copy events to the clipboard. The other thing that we could do is we could test. We can just test some random HTTP tags. So like bold or something. This is not bold. This is bold. Something like this. Yeah, but we don't see, this is not where we want to put our payload here, because these tags were not interpreted. Okay, so what do we got here? We got our tags, we've got our events, and we got our codes. So all browsers. Maybe, are we supposed to do it in alert? So solve the lab, perform a cross-site scripting attack that calls the alert function. Okay, so cross-site scripting, DOM-based. Let me take a look. DOM-based cross-site scripting. The most common source for DOM XSS is the URL, which is typically accessed using the window.location object. Is that what we're dealing with here? Location.search. How about a picture attribute? Maybe. Let me take a look at what the documentation says. It won't let me send an example. You could try. You try pasting something. I'm pretty sure you can put in code. There are certain special characters that Twitch doesn't like. So we got eval, we got inner HTML. Place data into the source so that it is propagated to a sink. Causes execution. HTML syncs, so location.search. Base MC25 says base 64 it. Are base 64 the payload? If we were to base 64 the payload, we would do something like echo out the thing and then base 64 it. So we would do the same thing with our script tags. Oh, the example. Oh, yeah, right. So MC25 says you can base 64 the example for Sozo. Okay, so what is this? In principle, a website is vulnerable to DOM-based cross-site scripting if there is an executable path via which the data can propagate from source to sink. In practice, different sources and sinks have different properties and behavior that can affect determine which techniques are necessary. Scripts might perform validation or other processing of data that must be accommodated for when attempting to abuse the vulnerability. Okay, there are a variety of sinks that are relevant to DOM-based vulnerabilities. So there's a big list. The document.write sync works with script elements. You can use a simple payload such as this. So document.write. Oh, okay. Are we just pasting this directly into some field? You passed the first DOM lab? No, this is the first DOM lab here. So let's go back to the lab. Alert. I mean, this is exactly what we're talking about. Is this going to... No. Document.write script alert document.domain script location.search. Script elements, okay. I mean, we tried this one directly. Do we put it in... There are a few different places where we can put the payload. We tried putting into the search here, which also ends up going in the URL parameter up there, right? That doesn't necessarily get it to execute. Same thing with using the search bar. Do we need to go into... Do we need to go into the into the developer tools and put this in via the console? Oh, okay. We put it in through the console here. But wait, does that solve the lab? Let's reload the lab. No, that didn't solve the lab, but it did run the payload. Okay, Sozo's got a base64 encoded string. Let me take a look at it. Don't run it in the console. Okay, well, I mean, I learned that lesson. Oh, okay. So we're escaping from something in this case. So we're escaping from the string. That's what you're talking about, Sozo. So we're talking about the previous script is going to be exited out, and then we start a new script. And we've got our maybe not exactly what we're looking for. Can we play around with this though? The blog generates the picture showing your result. Look at the JS on the side to see where your payload was injected. Oh, okay. So we got this here. So search results here is, this is the blog header. We got our script and oh, you know what we should what we should look for is this location.search. We should search for this inside of the web page. Well, I mean, location.search is up here, but okay. So document.write. Oh, we're looking for document.write. Okay, so it prints out image source equals search terms equal something something plus query. Oh, okay, okay. So we're working with this script tag. We need to inject into here. Kenji, hello, nice to see you here. What's going on here? Really hacking? We're doing hacking, yeah, but we're not hacking. We're not hacking anything that we're not allowed to hack. We're using education websites. So if you're interested in what we're taking a look at, this is it over here. So we don't do illegal hacking over on twitch.com and YouTube because if you do illegal hacking on those websites, they ban you. So we're not hacking illegally. Anyways, what are we doing right now? We're trying to figure out how to get our injection payload to work. So search terms equals something something plus the query. Okay, so if the queries go in here, I want to learn. Yeah. So if you want to learn more about web app hacking, there are all sorts of great places to learn. So probably the best one to learn from is portswigger.net. Living Prince says, do you know NoSQL vulnerabilities? NoSQL I haven't done a lot of NoSQL vulnerabilities, but you can learn them. You can learn about NoSQL stuff from the same website. Let me get NoSQL from PortSwigger. Here you go. Okay, so what do we have here? So all tags. We're talking about image stuff, right? Let's see. Let's see, script tags for source, image source. Maybe we're looking for image source here. Where is source? All events. On, what would it be in this case? On right? Name's Colin, by the way. Hello. I thought your name was Kenji because it shows up as Kenji. Hello, nice to see you here. Take the JS. The test takes your search and then injects it into the image HTML tag. Okay, so if you see a double quote before the script, will it escape? If you use a double quote before the, what are we? So we double quote and then we do our script tags. Okay, so I mean, it looks like we got something in here. Thank you very much for following, Khaled. Khaled, nice to see you here. So learn XSS. That gets put, sort of. Can we? I don't even know what I'm doing anymore. Okay, so use double quote and then, okay, so we'll do this at the end. Okay, Living Print says, I just wanted to ask, is NoSQL the same as SQL injection? It retrieves data from databases. I mean, it gets information from the databases, yeah, but the type of database that's being accessed, it's a different type of database. It's not an SQL database, and there's a few different popular NoSQL databases. The way you're doing the injection is slightly different. So the payload we want to run is just this. We need to wrap this with something that's going to get it to run. So we just run this. People are asking us to do what? Double quote and this. So it's either put this at the beginning or the end. That looks like it got a lot closer. We got it. Okay, we got it to work. Unique payload on searches like the Chiad to see where it's injected and what you need to escape. So we got the lab to run. We basically need to run this payload, but we need to escape from the other tag that's being used. So is that it? Yeah, okay. So it's this to escape the previous tag. So semicolon, double quote, and then bracket. And then we include our payload on the other end. Okay, it's only going to get more difficult from here. All right, let's move on to the next lab. So the next lab is DOM XSS. Wait, hold on. All the labs. This is SQL. This is cross-site scripting. Neem says, I think you were supposed to look at the source. They look already solved. Already solved? Which ones? These ones? Oh, this is because I went through these cross-site scripting labs a couple of years ago. I don't remember anything about cross-site scripting from back then because it's been over 3 years since I last looked at it. But let's try another one. Cross-site scripting, DOM XSS and inner HTML sync using location .search. Okay, let's do that one. So what is this lab? This lab is inner HTML. So the inner HTML sync doesn't accept script elements on any modern browser, nor will SVG onload events fire. This means you need to find alternative elements like image or iframe. Event handlers such as onload or onerror can be used in conjunction with these elements. For example, got element.innerHTML and then got image source equals 1 onerror alert domain document.domain. Okay. Well, I mean, we've got the payload here. Copy that. And is the lab running now? Let's run the lab. So if anybody is wondering if you can forget how to do hacking, you can forget how to do hacking very easily if you don't do the hacking on a daily basis. So there's all sorts of stuff that I used to study that I don't really remember how to do anymore because I kind of forgotten how to do it because I studied that stuff a long time ago. Okay, so what is this lab? Inner HTML sync. Okay. Well, I mean, a good thing to know is what inner HTML is in the first place. Let's do a little bit of research. What is JavaScript inner HTML? Neves asks, I was just about to ask, how do you retain everything? You retain everything by, it's kind of like working out or exercising. If you don't exercise the thing, then it's not gonna retain. So let's see. Part of the document object model and used to get or set the HTML content of an element. Okay. Inner HTML is going to retrieve HTML content to retrieve the entire HTML content, including tags and text. MC25 says, I watch streams. Yeah, it's time to work out. It's time to work out and remind ourselves what cross-site scripting is. MC25 says, I watch streams to remind me, of course. Okay, so inner HTML content equals something dot inner HTML. Content can be a string. Okay, so what do we have for the payload? Element dot inner HTML equals image source equals 1 true. Image source equals true on error alert. And it's gonna be an error because you're not supposed to use image source like this. Okay. So first of all, we can go over to the lab, and in the lab we can type in something like test. Okay, so we got test inner HTML sync using location.search. So let's see where test wound up inside the code. Test. Doesn't seem to be in here. What we're looking for is location.search or inner HTML. Okay, so inner HTML, so something document.getElement by ID search image inner HTML equals query. So the query we're going to include is our payload. So the payload is this. Inner HTML equals image source 1 on error alert document.domain. I mean, it couldn't be this easy, could it? Wow, it really was that easy. So we tried to insert an additional image, and because the image wasn't legitimate, it resulted in an error. And the error on error we do some JavaScript stuff, and the JavaScript stuff is going to solve the lab for us. Okay, let's reload that and let's understand what exactly is going on. Okay. So we inject the element.innerHTML, which is a bunch of stuff. ZGCG says, hello, I'm late. Can you put in your YouTube link? Yeah, let me get the YouTube link. Just a second, everybody. There you go. So on error, and because we're trying to create a new image source, and that's going to error out by default. So when the error happens, we execute this code. So I mean, this code could be XSS is here, brothers and sisters, search. Okay, so Soul Elementor says, how do you end up protecting against this? How do you protect against this? You need to code your applications correctly. So most of the time when you've got these kind of vulnerabilities in your web page code, you just need to code the web page correctly so that it doesn't take in user input as part of the execution of the program. That's how you do it. Okay, so I think we've got time. We might have time for one more. Let's get out of here. So sources and sinks and third-party dependencies. Modern web applications are typically built using a number of third-party libraries and frameworks, often provide additional functionalities and capabilities for developers. It's important to remember that there are also potential sources and sinks for DOM cross-site scripting. Sandovice says, don't put search bars or forms. I mean, you need to have search bars and forms. You just need to make sure that everything that is being put through those search bars and the forms is not vulnerable to anybody injecting code. DOM XSS and jQuery. So if a JavaScript library such as jQuery is being used, look out for sinks that can alter DOM elements on the page. For instance, jQuery's attr function can change the attributes of DOM elements. If data is being read from a user-controlled source like the URL, then pass the attr function. It might be possible to manipulate the value sent to cause cross-site scripting. We've got some JavaScript that changes an anchor element's href attribute by using data in the URL. You can abuse this by modifying the URL so that the location.search source contains a malicious JavaScript URL. Okay, so let's try loading up this lab. So return URL equals JavaScript alert. Return URL equals JavaScript alert. All right. I mean, this is what we're looking out for inside the... Okay, let's run the lab. Sorry, everybody. This lab contains a DOM-based cross-site scripting vulnerability in the submit feedback page. It uses the jQuery library's, what was it? $selector function to find an anchor element and change its href attribute by using the data from location.search. To solve this lab, make the backlink alert document.cookie. Make the backlink alert document.cookie. All right, let's go. Should be loaded up. Make the backlink alert. Okay, let's just bop around, submit feedback, return path. So feedback return path equals something. So we can put whatever we want for the form here, but what we want to do is we want to manipulate the address bar up here. So return path equals something. And we're going to inject into there. So return URL equals JavaScript alert domain document domain. But we don't want document domain. What does the lab want? It wants document.cookie. So we will put that there instead. Document.cookie. Okay, and then we solved the lab. We didn't necessarily get the cookie, but I think we get the cookie if we submit this. Subject. Oh, and we still don't get the cookie. I wonder how we actually get the cookie then. Anyways, okay, so I think we're just about done. let's talk about cross-site scripting. Jeez. I'm going to be studying more about cross-site scripting. I'm going to need to teach myself cross-site scripting again so that I can teach people about it, because it's been a really long time. If we take a look at these labs, I've solved a lot of them, but that was years ago. But we're going to be shifting into the last part of today's stream, and the last part of today's stream is we're going to be learning about a lot of easier web app hacking concepts over at OLIcyber. So OLIcyber is an Italian cybersecurity education platform that you can find over here. And we're going to be working through some of the challenges there. Don't worry that the website is in Italian. As hackers, we're able to do all sorts of translation because machine translation is very easy to do these days. So we'll demonstrate how to do this. Let me close up a bunch of these tabs because there's way too many tabs open right now. Okay, Sandovice says, do you do software fuzzing or reverse engineering? Yeah, we've done software hacking. We'll probably be doing software hacking and reverse engineering on Friday. So if you come by on Friday, you can fill your boots with all that stuff. Okay, let me change my overlays. So we're done with topic 3, done. Topic 4 is OLIcyber web app challenges. And if you're interested in doing reverse engineering and software hacking stuff, this is also a website you can do that. So what are we going to be doing? We're going to be doing the introduction challenges. So introduction challenges, they've got a bunch of different categories here. We got miscellaneous, we got network security, we've got web security, and we've done a number of these web security challenges already. We're just going to work through the web app challenges here. And if you take a look over here, we've done a number of these software security ones as well. So in this case, when we're talking about software security, we're talking about binary hacking and reverse engineering. So we're going to be doing that on Friday, but today we're going to be doing these web app ones. Let's put 60 minutes on the clock. We'll put 90 minutes on the clock, and then we'll start doing these challenges. Okay, so for each one of these challenges, we'll also be, let's see, OLIcyber, here we go, web app stuff. We'll also be doing a walkthrough. Okay, because what we really want to do is we want to get in the habit of documenting everything we do, because if you don't document something, you'll very easily forget it. So we're just going to do this one. The first challenge we're going to do is web app challenge number 8. Let's go ahead and we'll start our write-up. Okay, so in each one of these write-ups, and we're doing all the write-ups over here on GitHub. Let's see, we'll record the URL for the challenge, we'll record the concept, we need to understand the challenge, and the method of solving the challenge. Okay, so the first thing we'll record is the URL. So this is it. The concept we will know in just a bit. Okay, so we got a big description of the challenge in Italian, and what we're going to do is we're just going to copy the entirety of the description and we're going to put it into Google Translate, because I don't speak Italian. If you speak Italian, let us know and maybe you can help us out. Okay, so we're talking about post requests. So the representation of a submitted resource in the body of the post request can be in any format, etc., etc. Okay. So the goal of the challenge is to send a post request to the resource here, providing a value pair username admin, password admin. In the application xwww form in URL encoded format, similar to a hypothetical operation to submit a login form on a website. Okay, so the flag will be returned in the response text. So basically all we're doing in this case is we're sending a post request to the web application with specified data. Okay, so let's record that. So the concept: sending post requests, sending specific data to a web server via post request to get desired output. Okay, let's figure it out. So it looks like the MIME type is going to be application XWW form URL encoded, and we're sending it to this form right here. So everybody, this is the website we're going to be interacting with. So an interesting thing about the OLIcyber challenges is that they actually give you a Python file that contains the server code, or the code that is being used to run the server in this Python file. So if we download this, we can actually take a look at the code that's being used to run the server. Let me demonstrate. So we got am I looking at the right directory? Oh, challenge.py is here. Okay. So if you take a look at challenge.py, it's not a lot of code, but it's using Python to set up a Flask environment or a Flask server. And this is what's running the server. So post login to the login endpoint. So log on, username equals username, password equals password. If username equals admin and password equals admin, then check for the MIME type, text plain, otherwise return bad username or password. So what we can do is we can just do a very simple login. Actually, wait. Let me take a look at the website we're dealing with. So most of the time we can't solve this. We can't solve these challenges with the web browser. We have to solve them by using another tool. And in this case, we can solve it using the curl tool. So we curl and we access this website here. And we need to, hold on. We need to send a bunch of information here. So to send information with curl, you have to use xpost -x posts, and then we have to send a bunch of data. So the data we're going to send is username equals admin and password equals admin, like this. And I'm pretty sure we also need to send the correct MIME type as well. The correct MIME type, is it also sent as data? I kind of forget. Okay, let me ask a question. So the question is going to be, using curl, how do I send different MIME types? So MIME types are basically different file formats. To send a different MIME type using curl, use the -h or header for content type. Okay, so -h content type is going to be something something. Okay, let's try putting this into our curl command. So in this case, content type is what they want. They have something specific they're looking for. They're looking for application XWW form URL encoded. So this is what we're going to feed to it. So we're just gonna paste this in, and I think this is what the entire request is going to look like. I'll just copy this over to the chat. So we'll try sending the request, and we get the flag. Okay, that was all we need to do. Awesome. All right, so I'll just copy the curl command again, and we'll talk about this in our write-up. So the write-up is here. So the challenge asks us to send a specific post request to this endpoint, and the endpoint is this one over here. Okay. We need to send the username and password parameters in the request with values admin and admin respectively. Saint of Vices, I'll need to learn Italian. You don't need to learn Italian. You just need to learn how to use Google Translate. Because Google Translate is very, very useful, and you can use it to access cybersecurity education content in other languages. It's actually it's actually really, really cool. Because if I wasn't able to do Google Translate, or translate from other languages, I wouldn't have access to OLIcyber, and it's got like something like 500 different challenges that I can do. Okay, so where are we? Okay, we need to make sure that it is admin admin, and we're sending the username and password parameters. We also need to send the correct MIME type with the post request, which will be, what is the name of this thing again? Application XWW form URL encoded. Okay, so the curl request that fulfills all of the above criteria is as follows. Okay, we've got our curl command. Nope. Hold on, let me copy it. Here it is. Okay, just like that. Let's go ahead and complete our walkthrough. We will copy the flag, which is it. Sending data the old way. Great. And we'll submit this to the challenge. Okay, paste in the flag, submit. We're finished. Okay, let's move on to the next challenge. So the next challenge is web challenge number 9. And I guess we're sending JSON information this time. So request posts with body JSON. let's start our walkthrough to Web 8. Okay, next one is Web 9. Hold on, everybody. I'll give you the link for the challenge in just a bit. Okay, so we need the URL of the challenge, we need the concept to understand the challenge, and the method of solving the challenge. Gratitude says, do you plan to take the BSCP certification? The BSCP certification is a lot. It is really a lot. And if I were to study for the BSCP certification, it would take away from preparing for the live streams and teaching stuff in the live streams, because I don't only do web app stuff in the live streams. I also do network stuff. I do reverse engineering. I do cryptography every once in a while. And it really, I can't split my attention between studying for that certification and doing my on-stream stuff. So no. Mehmet, hello, nice to see you here. Welcome to the stream. Let's give you a Hack the Planet. Welcome on in.
Hack the planet! Hack the planet! Shut up and get in.
Okay, so this is the URL for the challenge, and I'll give everybody else the URL for the challenge as well. But I hope you're not too disappointed, Gratitude 2020, that I'm not going to be doing the BSCP certification. Okay, the concept in this challenge is sending JSON data in a post request. Okay, so the method to solve. The challenge is asking us to send a specific post request to this endpoint. What is the endpoint? Let's get it. This one over here. So it's the same. It's another login form. And what else? Okay, let's grab the description. We'll read about what the challenge wants us to do over at Google Translate. Okay, so XWW form URL encoded, despite its historical popularity, is an obsolete format and poorly suited to representing structured data. It's gradually been replaced in applications that do not require compatibility with traditional web form submission mechanisms by more modern formats such as XML and JSON. The latter in particular, due to the ease of use of JavaScript, is the most widely used web programming language, has quickly established itself as the new de facto standard. Libraries such as Requests offer shortcuts for sending post requests with JSON encoded bodies as easily as the old system. Okay. Similar to the previous challenge, the goal of the challenge is to send a post request to the resource over here, providing username admin and password admin values in a JSON format. Similar to the hypothetical login operations against a web service, the flag will be returned as the response text. Okay, so let's talk about this. The challenge, they also want us to submit these things. So it's username admin and password admin but in a JSON format, we can craft a payload in curl to send this data. And let's go ahead and get the command we're going to be doing. So it's going to be pretty similar to what we did previously, except it's going to be web9. And the content type is going to be, it's like, I think it's called like application JSON or something. Let me look that up really quick. Content type application JSON. So actually, wait. Let me grab this. Okay. So I'm just going to manipulate this stuff over here. So content type is going to be application JSON, and data is going to be key and value. So I mean, key value is going to be username admin and password admin. Kind of like this. Okay, so actually before we finish the challenge, let's go ahead and take a look at the code that is used to serve the application, because I'm pretty sure they include it in the challenge as well. Yeah, so challenge.py. Let's get rid of the old challenge.py file. And let's download the new one. Okay, download that file. So username request.json get username request.json get password. Oh, looks like we got some ads running on Twitch right now. So when ads run on Twitch, we run them on YouTube. I'm going to take a little break to take a little bit of water. But in the meantime, enjoy the birds. We'll be back in about 60 seconds. Enjoy the birds. I'm just going to have a little water break. Okay, let's put the birds away and let's get back to the hacking. All right, so return response json.jumps token environment flag, okay, and then MIME type application JSON. So they're going to send back some JSON as well. They're looking for request.json get username and password. They're looking for username admin and password admin. So if we send this all correctly, then we get the flag. So let's go here. I'm pretty sure this is all we need to do. Let's send the request. Okay, that was exactly what we needed to do. All right. So everybody, this is the command that we used to send the JSON request. Okay, and we can finish this up pretty quickly. So we're just doing our little write-up here. If you ever want to take a look at any of the write-ups that we do, this is where you're going to find them, at this link. Okay, so to finish the challenge, we need to grab the flag. Okay, and we will submit that to the challenge to finish it. Done. Great. Okay, and all right, I think we'll do 1 or 2 more of these. Actually, let's do 3 more of these and then we'll move on. We'll move on to some other challenges. Actually, wait, some of these challenges look like they might be kind of interesting. We got some SQL injection later on. Even some blind SQL injection and time-based stuff. So we'll see. There are a couple more of these not so super interesting ones, but we should probably work through them just so that we can say that we did. Okay. Next challenge. Let's create a write-up. So we're kind of working through some of the very fundamental basics of doing web app stuff, web app requests, and learning the ins and outs of using applications. So this is a pretty good foundation for learning about more web app hacking stuff. Not super exciting, but you know, fundamentals all the same. So the concept in this case is we're going to be using the options method. The options HTTP method. Okay, and method to solve. I'm pretty sure we just need to send another curl request in this case. Let me get the link for the challenge. Okay, so what is this challenge all about? Let's Google Translate this. Okay, so we've seen various ways to interact with the resources via for the HTTP server. So in the form of the get, head, and post verbs. However, not all these operations are supported by all resource types. So for example, it makes no sense to make a post request against a read-only resource. Okay, to find out all of the operations supported by a given resource, HTTP provides the options verb. An options request returns a list of supported verbs within the allow header. Okay, so this is what we need to do. We need to determine the set of supported verbs from the resource this over here. So we got a link, and try using an uncommon or an unexpected verb and observe the response. Okay, so let me get the website. There you go. Okay, so there's also the server. So the server code. Let's go ahead and get the server code. rm. Let's get rid of the previous Python script. Get the new one. Okay, so what's going on here? So we're just communicating with the web root right here. So they got methods get, head, options, post, put, patch, and delete. Response.headers allow head, options, and get. Head, options, and get. Okay, so this is what we're going to do. We're going to make a curl request to this endpoint here. And let's write about this. So the challenge wants us to make a request to this endpoint. Wait, did the endpoint have all those stars? To this endpoint and figure out which HTTP methods are allowed. we can do that by sending a curl request to the page with the options HTTP method. Okay, and let's get the curl command. So the curl command is going to be this. So in this case, we're going to send options. (401) unauthorized. Allow head options and get. Head options and get. All right, so this lets us know that the allowed methods on the application are get and head and options. I mean, we already sent options, didn't we? So options HTTP, yeah. I wonder why this one is unauthorized. But based on that, we're going to send the head method instead. And it still says unauthorized for some reason. I wonder what makes it unauthorized. Hold on. Am I using the correct endpoint? I need to check. Okay, let me take a look at the challenge description one more time. The goal of the challenge is to determine the set of supported verbs from the resource. Try using an uncommon and unexpected verb and observe the response. The request library. To find out the operations supported by a given resource, HTTP provides the options verb. In options request returns a list of supported verbs within the allow header. Oh wait, is this is the correct one, right? This is challenge 10. I've got the right website. Just in case, I'm just going to copy paste it again. Okay, and we're going to send options to it. Okay, so allow head options and get. So we sent head. It gives us 401 unauthorized. If we send get, it sends us unauthorized. So the method is not to use options, because when you send options, it says allow head options and get, but these are not the answers, because we know the answer if we take a look at the code. So we see here, if method not in head get head and options, response internal server error. So we actually get head options. There's get head options, post, put, patch, and delete in here, but we don't know this. The response is head, get, and options. I mean, we could try all these other ones. Actually, wait, which one gets you the flag? If method not in here, return response. If method get, return response unauthorized. If method options, response dot. Okay, so we've seen this. So which one gets you the flag? If method not in. So we need to send something that's not in here. which means we could do the put method, or the patch method, or the delete method. Let's try post. So if we just hold on. Okay, so we're sending this to 10. We're going to send a post method because that's not in the list of allowed methods. Okay, so I guess the solution was to not follow the rules. Okay, well, all right, let's go ahead and do our write-up. The options HTTP method. The challenge wants us to make a request and figure out which HTTP methods are resolved, and then we can give the options method curl v x options to this endpoint. So the server output tells us that we can use these methods: get options and head. The problem is that these methods don't get us the flag. And the web server code looks like this. Okay, and we will put in the code here. Copy, 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 paste. According to the code, if we send a HTTP method that is not one reported by the options method, then we get the flag. Okay, we'll point out the exact code over here. So we can send a post request to get the flag. Okay. So that's what the curl request looks like. Okay, let's go ahead and save these changes. That is one more walkthrough done. We will grab the flag and we will submit that. Challenge done. Okay. Oh, this is a CSRF token. This is actually an interesting concept for web applications. So this is yeah. Let's go ahead and start this off. So this is web app challenge number 11. So CSRF stands for cross-site request forgery, and we'll talk a little bit more about it while we solve the challenge. Saint Devices, might try some of these. I got hooked. Yeah, I mean, I really like the format that these challenges take because they're very educational. They give you all the information you need to solve the challenge, and they're like little lessons. I really like that. Okay, the URL, the concept, in this case it's CSRF tokens in web applications, and the method of solve. Okay, let me grab the URL for the challenge, and then we will get underway. Okay, we will, well, there's a lot of stuff in here. Okay, copy that, and then we will put this in translate. Okay, so the CSRF token is a system used to prevent cross-site request forgery attacks. The attack consists of tricking a user of a web service into clicking on the link or submit button on a form included on email and on a website, controlled by the attacker, targeting a malicious resource on the target service. Resource whose requests require an account deletion command, the session cookie mechanism, which can only be obtained by with a username and password unknown to the attacker, prevents the attacker from personally performing the malicious operation by impersonating the user. So CSRF tokens, they're meant to prevent abuse of web applications by making sure that each user has a unique token that they can use when they're submitting their request to the application. Okay, so CSRF tokens prevent this type of attack because it is not automatically sent by the browser like regular cookies. It is still stored on the client machine in the storage area, okay? This makes it impossible to trick the user into generating a malicious request with a simple click. Because you have to generate the malicious link, the attacker needs to know what the token is. So CSRF tokens are typically disposable, and for each successful operation, the client receives a new randomly generated token. The new token is typically appended to the body of the returned resource, okay? So what do we need to do? So in this challenge, the flag is divided into 4 pieces. Oh, okay. Flag piece based on the index parameter. To access this, you must have previously sent a post login request to the resource login with a JSON body containing the username, admin, password, and receive a session cookie in return. Okay. Surfer, hello, nice to see you here on YouTube. What is up? We're just, we're learning about some web app basics. Basically, we're learning about how web applications work and how to hack them. But first, we need to learn how these things actually work in the first place. We're using this Italian cybersecurity platform for today's exercises. Here you go. Okay, so there are 2 resources we need to use. We need to use the flag piece resource, and we need to use the login resource. Okay, before we go forward, I guess I also need to change up my music. Let's play some StarCraft. Music, that is. Okay, so to access it, you must previously send a post login to the resource. Login with the JSON body containing username and admin and password, and receive a cookie session cookie in return. In addition to the session token in the cookie, the login resource will also return a CSRF token in the response body, which is also JSON. For each successful request, the client will receive a new token to use for the next one. We recommend using a session object to manage the session cookie and the JSON method session object and a JSON method of the response object to automatically decode the body. I mean, I think what we need to do in this case is we need to write a little Python code. Otherwise, this is going to be kind of tricky. because if we just try to access these normally, it's not going to work inside the browser. So it says method not allowed. We need to post to this endpoint here, and then we need to go over to this other endpoint called flag piece. So it gives us an error, unauthorized bad session. Okay. I mean, what happens if we just use curl? Let's try using curl first. Okay, so if we're just sending curl requests, where's our curl request with the... Hold on. Yeah. So this is the one with our JSON information. We're sending this to web 11 to the login endpoint. Okay, so it says status OK, and it gives us a CSRF token. Same device as any resource for learning curl. Learning curl. I've basically been learning curl as I go, but you can always look at the official documentation for curl. Curl. You can take a look at like a curl cheat sheet. So there's one over here. Sure, why not? Oh, that is an ugly link. Let me get a better looking one. So dev hints curl, sure. And curl command cheat sheet and quick reference. Most of the time when I've got a question about using curl, I just Google it. Okay, so status OK, CSRF is this. So I guess what we need to do is we just need to submit this to the next. What is it called? Flag piece? Flag underscore piece. We need to send a custom header there, which is CSRF. Bad session. Bad session? Were we given a cookie? Okay. Oh, set cookie. We got a session cookie here. Okay. All right, we need to send this with a cookie then. So the cookie is going to be B. In between some quotes. Okay, now we've got bad CSRF token. Okay, let's try logging in. So we'll go back to the login. Okay, we got a new CSRF token, so each time we need to use the correct one. We've got session this, path this. Actually, wait, is the session, is the cookie the same each time? So 68DA. No, it's not the same one. Okay, so that means we need to switch out our session and our cookie each time. Copy that. I'm pretty sure we don't need the path in this case. We just need to switch out our CSRF token. Bad CSRF token. Wait, I'm pretty sure I used the same. Hold on. What do you mean bad CSRF token? Okay, okay. You know what I'm what I'm going to do? I'm going to take a look at the code for the server. Server asks, do you have a Saint Device says, I like doing stuff with the Twitch API, but their guide is limited. I honestly, I would try asking the AI how to interact with the Twitch API, because they probably have a lot of examples from the stuff that they've ingested. Surfer asks, do you have something like a roadmap for beginners? Yeah, here's the starter pack. So over here, there's a bunch of links for some YouTube playlists. So the first two are for basic IT stuff, which is good if you want to learn about, about technology in general. The third link is for computer networking, which is something that you're going to need to understand to deal with all the technology that you deal with when you're doing technical hacks. And the fourth link is for easy CTF cybersecurity challenges, which are on my YouTube channel. So go ahead and check out those links. It's a pretty good way to get started into hacking. And you know what else? There's the Discord server. So you can come into the Discord server and ask any questions you might have over there. Okay, so what are we dealing with this? So there's a post request. We need to send it. We need to, oh, we've got ads running right now. Okay, we got ads running on Twitch, so we'll also run them on YouTube. And we'll put on some birds. These are my favorite birds. We'll be back in about 60 seconds. Just need to have a little water break. Okay, we'll put the birds away. We'll get back to the hacking. All right, so we were running into some problems, and what we decided we wanted to do, we want to take a look at the code that is being used to run the server. So we're just going to go over to the challenge and download that Python script that is being used to run the server. We'll take a look at it. Okay, so this one is a little more complicated than some of the other applications we've been looking at. So flag environment, flag, okay, so flag piece length equals length of the flag divided into 4 pieces, okay? We're going to create a little database, challenge.db. CSRF, where ID equals token session. Oh, we're creating a bunch of CSRF tokens. Okay. So token equals session equals token equals this. CSRF. What happens when we make a request? Okay, CSRF equals this. Are they looking for something called CSRF, or are they looking for something called token? So this is important. Response, flag piece, CSRF, new token, session, and what are they looking for? Bad CSRF token. If token, okay, so they're actually looking for something called token. Oh, okay. I think I get it. So whatever we get as a CSRF, we need to send as token in the next request. Okay, so the cookie is going to be the same. Well, it's not going to be the same, but it's going to be in the same format. So it's this. Okay, but we're going to send token equals something instead of CSRF equals something, because they're looking for the word token. Okay, let's see if it works. Bad CSRF token. Okay, so maybe I'm not sending the JSON information properly. They want this, maybe they want the token as part of the JSON information. Let's check. Jug Pearl, hello, nice to see you here. Haven't seen you in a while, but welcome to the stream. We're doing some web app hacking challenges. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get in.
We're currently doing this challenge over here. We're using a new CTF platform that's in Italian, because we love being international here. But yeah, this website is pretty good, and there are something like 500 challenges on this website, and I'm excited to be able to do this stuff. Jugpearl says, I wish my school classes could be your Twitch stream. Jugpearl, what are you studying? Are you studying computer science or computer security stuff? Okay, so we're just taking a look at what the challenge wants from us. Okay, in addition to the session token in the cookie, the login resource will also return a CSRF token in the response body, which is JSON. For each successful request, the client will receive a new token to use for the next one. So are we... To access it, you must have previously sent a post login request to the resource login with a JSON body containing the username and password, and receive a cookie session. In addition to the session token in the cookie, the login resource will also return a CSRF token in the response body, which is JSON. For each successful request, the client will receive a new token to use for the next one. So do we need to send... We recommend using a session object to maintain the session cookie and the JSON method of the response object to automatically decode the body. Okay, this is more complicated than the other stuff that we've been doing. Flag piece, CSRF, new token session. New token session. So the post endpoint and the flag piece endpoint. What about the flag piece endpoint? Okay, so session equals cookies get session, token equals requests args get CSRF. Okay, so I'm going to ask the AI a question about the code over here, because I'm not completely sure. We got Claude. Let's ask Claude. According to this code, are we supposed to send the CSRF token as a header or as a JSON object? Okay. According to this code, the CSRF token should be sent as a URL parameter, query string parameter, not as a header or JSON object. So token is request.args get CSRF. So flag piece CSRF equals your CSRF token and index equals 0. Index equals 0. Index URL parameter specifying which flag piece you want to get, which is an integer, and cookie containing your session ID. Oh, okay. Okay. I think I understand. Or at least I hope I understand. All right, let's try to do this manually. Okay, so we get the CSRF token here, and we get our session cookie here. So the session cookie is this. We'll copy that. We've got our command that reaches out to the flag piece endpoint here. We'll paste in our session cookie. We don't need the token header. So we're going to flag piece CSRF equals the CSRF value here, and index equals 0. So index equals 0, that's the part of the flag we're looking for. Bad request, missing index. Missing index? How did that happen? CSRF and index. CSRF equals your CSRF token and index equals 0. Maybe the index starts at 1. Missing index. Did I spell index incorrectly? Index equals 0. You need to URL encode the and. Oh, do we? Okay. Yeah, it did get a little bit messed up. Okay. Well, I mean, yeah. We didn't need the URL encoded. We just needed to put it between some quotes because the and messed up. It messed up the curl command inside of our Linux terminal. Okay, so we got another CSRF. We need to replace the CSRF and then request a new piece. Yeah, okay. So this seems to be working. So index 0 and we got another CSRF here. Okay. So this is I mean, it's working. We just need to mix up the CSRF and the index of the whatever flag we're looking for, whatever piece of the flag. Get new CSRF, index 1, index 2, index 3 should be the last one. Okay, and we get the last piece of the flag here. Okay, so we just need to put these all together and we'll be okay. Pavan Teha asks, can you please explain to me what you're doing? So we're interacting with a web application, a website, and we're trying to get some secret information from it to fulfill an exercise. So the exercise is illustrated over here. The website that we're using right now is an Italian website, which means that we need to translate all the instructions from Italian to understand what's going on. But we're trying to work through some quote-unquote easy exercises that are in the web app hacking category right now. Okay, so this is the last piece of the flag. The third piece of the flag is here. The second piece of the flag is here. And the first piece of the flag is where? Here. Okay, so this is the entire flag here. We'll just copy the entire value and we'll submit it to the challenge to complete the challenge. Okay. Valid flag. Awesome, awesome, awesome. Okay, let's write about what we need to do. So CSRF tokens in web apps, method of solve. So the challenge asks us to contact one URL to get a valid session cookie. Valid session cookie and CSRF token. Then use that cookie and token value to contact another URL to get pieces of the flag for the challenge. Okay, so the URLs in question are and so these are it. So the login page is here. And the place where we get the pieces of the flag are here. Pavan says, just this month I have joined college CSE data science branch. What is CSA data science? So what does CSE stand for? Could you let me know, Pavan? Thank you. Thank you. Okay. Okay, so first we need to contact the login endpoint. And we can do that with curl. Oh, computer science, okay. Enrique says, this is actually so cool. Do you usually do this often? So we do a stream three times a week. We've got a Reddit over here. For our stream, we're called the HackerFrogs. And today is the Wednesday stream. So the Wednesday stream is all about web app stuff. And we're going to be doing another stream this week on Friday. So Friday, we're going to be talking about cybersecurity news. We're going to be talking about how to code and, well, how to use Python, the programming language. We're going to be talking about how to do software hacking. And we're also going to be working with our friend OreoByte, and we're going to be hacking some Windows machines. So you can also join the HackerFrogs Discord if you're so inclined by following this link right here. Okay, so what were we doing? I got sidetracked. Okay, so we need to contact the login endpoint. We can use curl for that. So the curl command is here? Okay. No worries, Enrique, no worries. Okay, so after that request, we receive a session cookie as well as a CSRF token value. We need to use both these pieces of data to access the flag piece endpoint. Pavantea says, thanks for letting me know. I'll try to catch up in my free time. No worries, no worries. And good luck with your studies. Okay, so something like this. Okay, so let's go back to the challenge for just a second. So it's an interesting thing that it actually doesn't tell you. It doesn't tell you. It does tell you about the index parameter. It doesn't necessarily. Does it tell you that the CSRF has to be used as a URL parameter as well? Let's take a look. Okay, so you must have previously sent a post login to the resource JSON body. Okay. The login resource will also return a CSRF token in the response body. For each successful request, the client will receive a new token. So what is the word parameter? So based on the index parameter, this is where we understand that we need to send the number we want as the index parameter. But CSRF tokens, I guess we should know. We should know that CSRF tokens are typically sent as URL parameters as well. Anyways, let's complete the walkthrough here. So note that both the CSRF token parameter and the index parameter must be sent in the URL to access the piece of the flag. Okay, so I think repeat this 3 times to get the entire flag. Okay, I think we're done. Let's move on to the next challenge. what is the next challenge? Web 12. Okay, so Web 12 technology, web, something about web pages. I don't speak Italian. We could probably translate it. Sure, let's translate it for fun. Extracting simple content from a web page. Extracting simple content from the web page. All right, let's start up our write-up. Okay. So what I'm doing right here is I'm setting up the write-up that I'm going to be doing for this challenge, because we need to document everything we do. Okay. Okay. And let's grab the URL for the challenge. Here you go. Everybody, if you want to try this out along with us. And I really recommend doing these challenges with us, because it really helps you get a sense for completing these challenges on your own, because you definitely want to try these challenges on your own eventually. Okay, so I think what they want us to do is they want us to use Python, like a Python script, to complete these challenges. I mean, we could use a Python script to complete these challenges as well. We might go back and do these challenges with using Python eventually. But if we can do it by using manual methods like using curl, it's probably easier to do that instead. But let's okay, what is this challenge? So in this challenge, the flag is contained in the second paragraph of the web page accessible at this URL. It is recommended to download the page as a regular resource using the request library's get function and the Beautiful Soups library's find all method to get a list of the paragraphs it contains. So we can probably solve this challenge using curl and a bunch of Linux foo. I'll demonstrate what that looks like in just a bit. Okay, so one more time, what do they want from us? The flag is contained in the second paragraph. Okay, so it's contained in the second paragraph. All right, let's Gaussian parsing web page content. That's not how you spell parse. Okay, so the method to solve, we need to visit this web page. Let's get that web page. So in the web page content, the flag will be in the second paragraph of the page output, of the page contents. Enrique says, what do you think of the HTB certification? Is it worth the investment? Which Hack the Box certification are you talking about? I think the certification you're talking about is the pen tester one. So let's see. Hack the Box, what is it called? certified CTFs. This one, right? You're talking about this certification. If you're talking about this certification, I think the skills that you get. Enrique, are you a student? Are you a college student? If you're a college student, I think it's a really good investment because you can get the CPTS at a really steep discount if you're currently in school. So if you're a high school student or if you're a college student, it's a really good investment, I think. About to graduate, I think you should sign up for Hack the Box while you're still a student. And if you're still a student when you sign up for this, you can get the discount. I'm not completely sure how you get the discount, but you should. And Enrique, let me know what country are you from? Are you from the United States or from somewhere else? So Hack the Box Academy student discount. So getting a student subscription. So Hack the Box Academy student subscription discounted for students. Here's an article. A guide on how to get the student plan. Let me provide that. Oh, you're Canadian. Awesome, awesome. Here you go. Here's the article. I am also Canadian. Wait, are you around Vancouver? If you're around Vancouver, then you can meet up in person with all the cool people that I hang out with at the Vancouver cybersecurity groups. But if you're from another part of Canada, that's fine too. Anyways, let's put on some ads. Okay, so advertisements, let's put on some birds. These are my favorite birds. All right, everybody, we'll be back in about 60 seconds. Enjoy the birds. Okay, so we'll be back in just a second. So Enrique says that they're from Toronto. That's fine. Toronto is fine. Let me see if I can find a group, a cybersecurity group that meets up in Toronto. Okay, so here's a link. Enrique, here's a link that you can check out. So DEFCON 416. Then let's see if they haven't met up in a while. Another thing that you could look up is you could look up Toronto OWASP groups. Because OWASP is web app security in particular, but the people over at these meetings, they usually have an interest in all sorts of cybersecurity stuff, not just web app stuff. But get to know these people. Go to these meetings, meet the people. There's always going to be a lot of professionals that are hanging out at these in-person meetups. Okay, so get the student subscription. Definitely get it. Definitely take advantage of this before you graduate so that you can save a lot of money on this stuff. Okay, so we've got index, we've got the flag will be in the second paragraph of the page contents. So what can we do? We can use curl to get the page contents, then parse through the content using Linux commands. Okay, Enrique says, I'm mainly trying to network. I'm trying to build my own home lab too. Yeah, these are all great. These are all great things you can do. Definitely do the home lab. Definitely learn and get the certification on Hack the Box. definitely hang out with real people who do cybersecurity stuff as their job, because you can really you can get jobs through these contacts if you get to know them well enough. Okay, so let's go ahead and use curl. So we're not told that we need to log into this thing. So this is challenge 12, right? Okay. So, I mean, the flag is right here. It's the second thing. How can we parse through this? So we're looking for we have to delete everything before pre. There's pre here. Actually, we just need to get everything between this. Then again, let's see. So this is the first paragraph here. This is the second paragraph. Neems says, I'm trying to get an associate pentester part-time job. Any advice? An associate pentester part-time job? Any advice? Part-time jobs are going to be hard to get because people want you for full-time. But Neems, what do you live near a big city, Neems? If you live near a big city, the same recommendation for you is the one that I give to Enrique. Basically, get to networking. Network with do some social networking and meet some in real life people. New York, yeah. I mean, New York has a really big cybersecurity scene. So let's see. New York DEF CON group. Okay, let me see if this DEF CON group is actually meeting up on a regular basis. Jonas says you can use Python in Beautiful Soup. We could. The first way we're going to be solving these challenges is just using curl, but I think we're going to be going through and using Python to solve the challenges afterwards. Just a second. I mean, I've got this meetup group right here, but I don't seem to be able to load up the page. If you can load up the page, then go ahead and check that out. Same thing with the other user I was talking to. New York probably has a really active OWASP group as well. Yeah, so it looks like the OWASP group for New York is pretty active. Take a look over there. I've left the links in chat. Okay, so what do we want to do? In Linux, we want to retrieve only the content of a web page between the second pair of paragraph tags. Paragraph tags. How do we do that? Okay, sed is the most reliable, so curl and then sed, and then only the second pair. Okay, let's see what happens if we do this. So curl the thing. Oh, that's not it. Let me copy this. Okay, so did we delete all of the all the paragraph tags? And then what did we do? Hold on, everybody. I just need to load up my next set of music. Here we go. Okay, so sed 2p. What is 2p? Well, I'll find out in just a second. Better approach, most reliable, better approach with awk. Using grep with Perl regex if available. That's funny. Hold on. We can probably grep this as well. So we can grep for a pattern. So grep for the pattern /p. We need to put this between some quotes. Okay, well we got the p, the /p's, and we can get whatever is. What do we get? What is between them? That's the tricky part. They suggest better approach with awk. Okay, so awk. That looks. This looks. More practical example using pup HTML parser. So I don't know if this is installed by default on PUP. Yeah, it's not installed by default. Zen asks, hey, Shaihan, I'm new to cybersecurity. I know about PicoCTF, and for practice, do you have any other resources to learn cybersecurity more efficiently at a deeper level? So what part, which aspect of cybersecurity are you looking to learn? Wow, this worked really well. So, okay. Do you have any resources to learn cybersecurity more efficiently at a deeper level? Are you talking about everything? Because cybersecurity is really deep. Are we talking about network security? Are we talking about web app security? Are we talking about software hacking? Are we talking about reverse engineering? Let me know the subject. I mean, my answer for all the subjects is basically the same. I've got a bunch of educational resources. So I've got educational resources over here. Here. So you can basically take a look at the links in these different GitHub pages. So we got stuff for digital forensics and network hacking and programming and all that other good stuff. Take a look. For example, if you want to do programming, I've got a bunch of courses for Python over here that you can take. And if you wanted to do like web app hacking, we have a bunch of courses that you can take over here, as well as some other courses, some other websites you can do for CTF. But yeah, for some reason this works out really well. Anyways, I'll just leave this as my solution for the manual solution, the quote-unquote manual solution. It says, I want to learn coding from a fresh start. Which coding language should I learn? I mean, I'd say in general, Python is going to be the best bet because there's so many resources for Python and basically everybody uses Python. If you go into more specialized fields, you might want to learn some other programming languages as well. It's from a beginner's point of view, Python is probably the best way to do it. So I'll just give you the links for the Python resources over here. There you go. So we've got 70 hours of courses that you can take completely for free. It is really nice. So go ahead and try these courses from the Python Institute. Okay, let me get that flag. So here's the flag. No worries, everybody. I'm here to help. Submit the flag. Done. Okay, and then what do we have here? So web technologies, what is this? So let me take a look at the challenges that have the least number of solves. So the least number of solves is the SQL injection challenge over here. That makes a lot of sense because this is time-based SQL injection. Okay, what about these other challenges? So the numbers keep on going down. Huh. What we could do? We could start using Python to solve these challenges because we did study Python today, so it's a good opportunity to start writing some little scripts. Okay, so what do we got over here? So this is the first challenge. All right, let's go back. So let me save this out. We'll start writing some Python code. Oh, I didn't do a write-up for Web 1. So I should probably do that. So Web 1, let's do the write-up. Okay. Web 1. So this is actually going to be a little bit more fun because we're going to start writing some Python code to solve the challenges for us. Okay. So we're going to record the URL, the concept, and the method of solving the challenge. Let's get the challenge. It's over here. Jonas says Python is better than awk. Well, I mean, Python is certainly a lot more versatile than awk, sure. It's whatever, tool for whatever situation. Oh, they're asking us to do requests in Beautiful Soup here as well. Interesting. Anyways, all right, let's okay, so that's the link. The concept is using GET requests. So the method of solve, we'll do a method of solve for both Python and curl. So let's see. So this one is curl, and the other one we'll do is for Python. All right, let's take a look at what the challenge is asking us to do. Oh, hold on. Why is this so long? Okay, so what do they want from us? The goal of the challenge is to obtain the text of the root resource of the server identified by the URL this. I mean, can we just solve this with a web browser? If we just... I mean, we can just solve this by using a web browser, but you know what? We're not going to just use a web browser. We're trying to use Python. We're trying to use other tools. Federico, hello, nice to see you here. Parlo Italiano. No, I don't speak Italian. I don't speak Italian, but we are using this website over here. It's called OLIcyber, and it's it is an Italian website. I've already solved this one, right? Yeah, I've already solved it. But yeah, here's a link. If you're interested in doing these, if you're interested in learning cybersecurity and you also know Italian, then this is the site for you because it's Italian and it's cybersecurity. Okay, yeah, it is really good. I am very, very impressed with the quality of this website. Okay, so let's solve the challenge by doing curl. This one. Hanky says, "Thanks for sharing." Yeah, I'm here to share. I'm here to teach. I'm here to learn all those good things. Okay, so we're just going to curl this thing down, and that's all we need to do. Okay, just use a GET request to the URL in question here. Curl Python. So Python, it's been a while since I've used the request library, but we'll write up a little script. So nano web01.py import requests, and okay, so requests module Python. Python request module. So we'll just take a look at the article from W3 Schools. Can we make this dark mode because it's burning my eyes? So import requests, the request.get. Okay, so all we need to do is request.get like this. So generally what we want to do with these type of challenges is we want to set up a URL parameter or a URL variable. So in this case, the variable is going to be this thing. Where is the thing? Just a second. This. Here? Okay. So this is going to be the URL. So we're going to do let's say get request equals request.get, and we're going to plug in the URL there. And then we're just going to print out get rec. And we'll see if it works. It doesn't get us the actual contents. Okay, well, what do we need to do next? Okay, so download and install, sure, syntax, methods. So let's see, delete, get. Does this not teach us how to get the contents? The HTTP request returns a response object with all the response data. Okay, so the response data, let me, Python requests module examples. You get .text, you need .text to get the text response. Okay, so is it just .text? Response.text. Okay. Nano web 1 get request is this. Request text equals get rec dot text. Print rec text. All right, run the thing. Okay, so it actually gets us the flag. Great. Yeah, so let's record that. And thank you very much, Henke Lodwig, for giving us the lowdown on the method we need to do. Or what is it called? What is it called? It's an object statistic or something? Sick in the mind. Hello, nice to see you here. We're just writing some really basic Python code. Hello. Do like me some web stuff. It's not super complicated web stuff, but we're trying to figure out how to do Python to do some very simple requests. And actually, it's not a bad thing to figure out. Okay. So we're basically doing a bunch of challenges over here from the OLIcyber website. And if you haven't tried it out yourself, it's a pretty good website. It's not just beginner stuff, but there's actually a very good series of beginner challenges that teaches you a lot. So in the description of each of the challenges, they tell you all about the technology that you're going to be interacting with. And I'm very, very impressed. So the stuff they have here for web app security, very, very good. The stuff they've got for software security, also good. I'm actually looking forward to taking a look at the cryptography stuff, because cryptography it's my weakest discipline as far as cybersecurity is concerned, and I really want to get better at doing this stuff. So anyways, let's go back to the second challenge. So second challenge is here. Let's do a Python version of solving the challenge. Oh. Okay, yeah, so URL parameters. Did we not? We didn't finish writing this write-up. Huh. That's funny. Okay, so how do we solve it with curl? How do we solve it with Python? Let me look back at the challenge one more time. Okay, so the goal of the challenge is to obtain the resource server records by specifying the ID parameter with the flag value. So ID equals flag. It is recommended to use the param keyword of the get function illustrated in the previous challenge. There's a param keyword? I didn't even know. Anyways, let's, so you're looking for ID equals flag. Okay, so let's plug this in, and ID equals flag. Yep, that's all we need to do. Okay, so let's figure out how to do this with curl, and let's figure out how to do this with Python. So with curl, all we need to do is supply the URL with the parameters plugged in. It's not how you spell it's plugged. Okay, and for Python, this is what we're going to do. I'm going to make this into Web 2. Okay, so the URL has changed. So it's Web 2. Request.get URL. We need to add on to this, I guess. How do we send URL parameters with the request library? Okay, so let's see. Okay, Python's request library guide. We also have this one for Geeks to Geeks. And the easiest way to do this was probably, listen. The easiest way to do this is probably just have the AI do it through the Google interface here. So Python request module, URL parameters. It'll probably give you the answer immediately. Okay, define the URL parameters as a dictionary. So payload, response equals params equals payload. So yeah, it's all you need to do is give the URL parameters that we want to put in there. So payload, I mean, I wouldn't call it payload. I would just call it parameters. Or let's just call it URL parameters. We'll call it URL param, so it's not super long. So we just need ID to be equal to flag, and that's it. Okay, so get request is request.get URL and URL params. Or is it params equal? Params equals something. Okay, and then the rest of it is completely the same. We'll save this out, and we'll run the darn thing. Not found. What? Hold on. Something in the code is faulty. So ID, it should be ID equals flag. Oh, I sent it to the wrong resource. So the resource has to be this one, server records. Okay, let's go back. Okay, we'll write it out, save it, run it again. Done, 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 done. Done like dinner. Speaking of which, hold on, hold on. We'll do this. We'll go on for another 30 minutes or so, and then I need to go and get some food. Super, super hungry. Okay, so this is all we need for our code. This is actually it's a good exercise learning how to do this kind of stuff in Python, because every once in a while you're going to need to use some Python code to do some web app hacking attacks. GG, thank you very much, Hanky. Okay, so let's put in the code. So the Python code is here. Done. Okay, so Python, Python, Python. Let's do web app number 3. Okay, so HTTP request headers. According to the code, there's a request header, xpassword with the value of admin. Then the flag will be returned by the app. So we just need to feed this custom header. So xpassword admin. So this is the curl method. We'll also record the Python method. So this is curl, and we'll write the Python one. What is the URL? Here it is. Okay, so we'll rename web2 to web3. Start writing it. So for this challenge, we don't need URL parameters, but we do need custom headers. Hello, nice to see you. Thank you very much for IDSec? I'm not too sure how to pronounce your name. Leafon, hello, nice to see you here on YouTube. Let's give you Hack the Planet. Welcome to the stream, everybody.
Hack the planet! Hack the planet! Shut up and get in.
We're just writing some Python code to solve some challenges over on this Italian website. So this is an Italian cybersecurity education website. We're not doing any illegal hacking. Please don't ask me to do illegal hacking. Thank you very much. But it's okay if a website is not in your native language. You can always do your auto translate and get your education that way. Okay, so what are we doing here? So in this case, we're dealing with custom headers. And in this case, it's what is it called? xpassword. xpassword equals, what was it, admin? Okay, so xpassword with a value of admin. So I guess in this case, the request is going to be URL and headers. Headers equals custom headers. Didn't know about OLIcyber. Seems cool. Yeah, it's a very good platform. That's why I've been doing a lot of this stuff on stream. Okay, so let's see if this works. Run the Python code. Done. Wow, that was very, very easy. Okay, so this is how you send custom headers with the request library. Very cool. Okay. Python code, done. Save it out. Move on to the next challenge. So we're just we're getting more Python practice today. So concept: HTTP request headers and the HTTP accept header. So the application uses the following code. Okay. The code has one set of data that is returned if the content type is set to JSON, and another set of data that is returned if the content type is set to XML. The flag is in the XML data. The default content type is JSON. Okay, so we need to send a custom accept header in order to get the response we want. So this should be pretty easy if you're doing it in Python. It's just sending another custom header. Okay, so this is the curl method of solving the challenge, and this is the Python method. Just a second. I'm going to rename this file to web4.py. Okay, so what is the endpoint? So the endpoint we want to contact is this is challenge number 4. Okay, so we need to contact this endpoint. Okay, so we just need to plug this in. So the custom header in this case is going to be accept, and we need to accept something application XML. Okay, so I think that's the only thing we need to do to finish the challenge. Everything else can stay the same. Okay, so in the output here, we've got the flag. So it's all good. All right, done. Okay. Oops. Let's finish editing this file, and then we are done with this level. Okay. Commit those changes. Done. Let's do one more of these challenges. Then we'll reconsider what we're doing for the last I don't know, 15 minutes of the stream. Not a lot we can do. Actually, we can send cookies. This is pretty cool. Okay, so we just need to figure out how to send cookies using the request library. Shouldn't be super difficult. Let me go ahead and set that up. Whoops. Okay. So I guess instead of custom headers, we can just call this cookies. Cookies, just in case, I'll call it my cookies, in case the word cookies is some sort of special keyword. We're going to have to set this cookie to something we don't know yet. In here, we'll do cookies equals my cookies. Okay, so let's get that URL. Here it is. And the cookie is password equals admin. Great. password equals admin. Okay, save that out, then run Python. Done. Very tasty cookies. Okay, let's copy the code. We'll provide it to the write-up. Okay, let's call this the curl solve and Python. And we're done. All right, so we've got 19. It only took 2 minutes to solve that challenge using Python. That's pretty good. What are we going to do for the last 15 minutes? I think, let me try a stab at another challenge. So we were doing the maze challenge. I'm not going to bore everybody by doing the maze challenge on stream because it's Second of Mind says, once you get the base template down, it's pretty solid to go forward with it. Yeah, I really enjoy that. I really enjoy being able to switch things out and then getting stuff done the easy way. Definitely, definitely. Okay, so Hack the Web. The first challenges on Hack the Web are very, very easy, and they're definitely suitable for people who are not technically inclined. It's just about interacting with new pieces of technology. But as you go, the challenges become more and more difficult. And you know what? This seems like it would be a challenge that has to do with web stuff because it's called Post It. Let's check it out. Okay, so this is Hack the Web, Post It. Let me start doing my write-up for this. Okay, Hack the Web. Which challenge is this? This is challenge number 43. And so if you want to check out this challenge, log into the website with these credentials. So username is demo, password is htw123. Okay, so let's do the write-up. (043) post it. Okay, Second Amendment says, one thing that doesn't translate very well are certain key characters that are auto-converted by Python APIs. The only way to send with Python is to send a manual byte and to prevent it from being converted. For example, the greater than character, the less than character, for attempting to inject XML payloads. Yeah, sometimes when you're dealing with special characters in Python, that can get a little bit tricky. Sometimes you got to fight the Python. Okay, URL is here. The concept. We have to do the category where the challenge would fall into. Method of solve here. Okay, so this is definitely going to be a web app. Web app hacking. Well, it's not really hacking, it's just web app stuff. The concept is sending post requests. This is just what I'm guessing from I'm guessing all of this from the name of the challenge itself. Okay, let's see. Interesting. Second Mind says it's not Python, it's it actually happens in both Python, Go, Ruby, and I think I'd use curl with a very unique switch. So it's more about doing stuff on the command line. Is that what you're trying to say, Second Mind? The answer to this challenge is Clamock. There's no input field for this challenge, but that shouldn't stop you from sending this challenge answer to the website. So I mean, we're talking about some curl stuff. So this is the URL. We just need to send it with curl. I mean, I'm going to need to get my cookies. So unfortunately, getting the cookies is a bit of a pain, but let's go ahead and grab those cookies. Web developer tools, the cookies are in storage. So connect.sid is the first one. And the other cookie is, I think it's called something like HTW language preferences. Sailman says, not really. It's just becoming familiar with some of the limitations on what kind of characters each scripting language or compiled language will send with the native classes and methods like Python, how Python uses requests. Yeah, I mean, every time you interact with technology, it's got its own idiosyncrasies, its own little tricks you need to know in order to get the job done. And I think sometimes it's all about knowing how to interact with the technology. It's kind of like a hack. Anyways, let's grab that second cookie. The second cookie is HTW language preferences. And that is English. We need to send this as a post request. So X post. And we need to send some data. So the data, all we need to send is the answer. And it's Klamock. Is that something in German? I learned so much about foreign languages through hacking. It's kind of funny. Let's translate it from German. There we go. Slapstick. Okay. All right, so is this going to get us our answer? Wait, did I? The other thing we need to do is we need to check to see if we actually completed the challenge. All right, let's check. Okay, it doesn't say that we've completed the challenge, so I guess we haven't. Pretzel Pete, hello, nice to see you here. What is up? That shouldn't stop you from sending the answer to the website. So, okay, we sent our curl request, the post as post. So the data was Klamock, and we sent it with our accurate cookies. I don't understand why we didn't complete the challenge. There's no input field for the challenge, but that shouldn't stop you from sending the answer to the website. So is it answer equals Klamock or something? Let's take a look at the page. So it actually doesn't. So usually the data that you send has to be, it's a key value, but I'm not too sure what the key is. Is it answer? Or is it something else? Anyways, we'll try getting some hints from the page. Okay, there's a bunch of hints we can get here. Okay, let's start with the first hint. translate this thing. Post it? Yeah, I mean, we posted it. You want to have the answer box. You're not looking for a variable, you want to have the answer box. So I mean, this is what we have right here. I'll put this in chat. There might be something wrong with what I have. So this is it's a post request. We're sending this information right here, clawmock. This is the answer. Oh, you know what we should do? We should probably take a look at the format for the other challenges. Okay, so let's go back. So how do we do this post request? We'll just take a look at the box and see how it takes. So name answer. Okay, so the name is answer. So ID equals challenge answer, name equals answer. So answer equals clawmock. Did that work? Clawmock is correct. Okay, so that was the correct answer. Okay, let's record this. Then we're done. So if we go back to our map, we see that we've solved the post-it challenge. Okay, so we are told the answer for the challenge. We just need to post the request to the website. Okay, commit those changes. We're done. Can we do one more challenge? So we got Cypher, we have Freedom, we have Maze, we have Say It, username 3, and we got Community Archive. We've got new territory, phone number. I think this might be interesting. I haven't dealt with numbers in a while. Today, landlines are rarely used. Other technologies have replaced them. Let's stop time for a moment and remember these sounds. So are we talking about taking in dial tones and turning them into numbers? This is interesting. I wonder if there's a Python module that does this. So Python dial tone to numbers. Okay, generating DTMF tones, which are dial tones associated with phone numbers, can be achieved in Python using libraries like NumPy and this thing to synthesize and save audio. Okay, so extract phone numbers from an audio strip. Let's see. Let's take a look. There are a few different GitHub projects over here, but I would rather use an official Python one. Decode the dial-up sounds using spectrogram. Okay, so Hey, you know what? I might not be up to doing this kind of challenge right now, especially since we only have 5 minutes left. But we might do this next week. Anyways, it seems like it might take a little bit too much time. How about we take a look at another challenge instead? What might be super fast? Cypher might be super fast, or it might not be. Let's try Freedom. Or say it? Let's try say it. Oh no, this is more audio stuff. How about freedom? Oh man. Okay. Anyways, if you want to, let's take a look at the challenge. I'm pretty sure I can't solve this in 5 minutes. Hack the Web's map gives you the freedom to go your own way, and this freedom is also used here with pleasure. This creates a lot of individual game states that are nice to look at. In this task, calculate the exact number of different scores. Limit yourself to a small selection of 11 tasks in the initial area. The current map may differ from the image. Use the version shown here. The edges of the count are directed from the start. If you have solved calculator, Rot 13 will be unlocked, but not the other way around. Okay, and example 1, no tasks solved yet. Example 2, 2 tasks solved. So if you solve this one and this one, then all these other ones open up. So 4 tasks solved is irrelevant in which order the tasks are solved. As long as they lead to the same map, they count as 1 score. The exact number of possible game states is the answer. Oh my god. All right, I think it's dinner time, everybody. All right, so before we go, let's talk about what we're going to be doing on Friday. So today's Wednesday. We did web app stuff for a while, and yeah, sick in the mind. I've got dinner on the mind. So Variety Fridays. That's going to be the last stream of this week. We're going to be doing cybersecurity news. We're going to be talking about all the great news happening this week. We're going to be doing HackerFrogs AfterSchool, looking at more Python basics. I think we're going to be doing if conditionals and Boolean values. And then after that, we're going to be doing a little bit of software hacking over at OLIcyber, where Byte says dinner is always good. And we're also going to be doing a Windows Active Directory challenge over at the HackSmarter website with OreoByte, who just showed up in chat. Hello, OreoByte. Nice to see you here. And yeah, looking forward to hacking some Windows with you on Friday. All right, so everybody, to finish out the stream, let's find some awesome people to raid into. We got Hetanis, we've got BlazeBytes. Which is, I'm not too sure who we should be raiding into. Maybe let's take a look at what they're both doing, and then we'll decide from there. Hetanis is doing gaming. Okay, so we'll, unless BlazeBits is also doing gaming, will be okay. So let's go ahead and Hack the Planet, cybersecurity news, and Q&A. Awesome. Oh, not bytes. Okay, BlazeBits. Right. Okay. Let's go ahead and raid into BlazeBits' channel. How do you spell his name? Okay, everybody. When you arrive on BlazeBits' channel, if you could give this message: OSFrog hip hop hack, OSFrog, I would really appreciate it. All right, everybody. Once again, if you want to join the Discord, here's the link. Everybody, thank you very much for watching today, and we'll be back on Friday. We're raiding into BlazeBits. Ready? 3, 2, 1. HackerFrogs out.